Good morning, everybody. I'm Stefan Kobut. I'm the founder of Ethereum and RockLogic. And we will do a workshop together to set up an Ethereum node with different kinds of services. First of all, some facts about us. RockLogic was founded in 2012, not actually as a blockchain company, but an IT infrastructure company, DevOps company. We develop Ethereum since 2020. So already before the genesis of proof of stake of Ethereum happened, we started with the development. We're institutional node operator, so we use Ethereum also for our own operations, which include the staking efforts in Lido. We already performed a couple of security audits for Ethereum to ensure that everything is running fine and we don't overlook some major security vulnerabilities. We also won some awards. I guess the most recognizing, at least in Austria, is the Austrian Blockchain Award 2021. And this year we founded a separate company for this great product. And also this year we launched Ethereum Plus, which is in addition to Ethereum, a hosting service that you don't need to care anymore about where you get your own machine for Ethereum. So some use cases for Ethereum itself. Ethereum is open source. Everybody can look at the source, of course. And everybody can use it in whatever way they want to. It's MIT licensed. It means you can also fork it, rebrand it, whatever you like to do with the source code. It's up to you. Some use cases, of course, are staking. We, as mentioned, use it for ourselves, for our own operations with Lido and other protocols. There are also protocol node operations for OBL and SSV, so it's very easy with Ethereum to set up a Lido CSM operator as well as OBL or SSV operators. Then it's also possible that you run your own clusters with OBL and SSV. In case you don't know, OBL and SSV are DVTs, distributed validator technologies, that help you spread one validator key over multiple servers to ensure more reliability, more resilience to technical issues or other issues that you might face. Of course, you can also use Ethereum as an RPC node. Maybe some of you guys already use Infura or some other RPC provider. And you know that you're limited with them. But with your own node, you're basically just limited by the hardware you're putting Ethereum onto. We have users that run arbitrage bots on it. We have users that connect their MetaMask on it. That's pretty easy and will be explained also later. Of course, you can start developing your own decentralized app with Ethereum because you have the full range of RPC requests that you can use, as well, of course, as WebSocket. And of course, Ethereum runs everything you want to. You're not limited to the stuff that we provide you. You can also come up with custom services that you integrate pretty easily. That will be also explained a little bit later on. As you may know, Ethereum has multiple clients. First of all, we have execution clients and consensus clients. Both clients are needed to ensure that you can run a full node or an archive node. We support most of the recent clients, most of the major clients. We also look always into some smaller clients, but up until right now they were a little bit too unstable to integrate. And we want to make sure that the user has a seamless experience in running an Ethereum node. So how do you run an Ethereum node? First of all, you can run it on cloud or on your home PC or your office computer, wherever you want. Of course, with cloud, you have AWS, GCP, Hetzner, and our new product, Ethereum Plus, of course, which makes it very easy to use with Ethereum. With ARM, it's a little bit complicated. You could run a full node with Raspberry Pi 4, but it's a little bit slow, so I would not recommend it. If you want to use ARM, I would really recommend the Rock B5B or the Orange Pi 5. It's a much smoother experience, especially on mainnet. With x86 machines, generally just choose a CPU with a benchmark over 20,000. That's, for some that might sound a lot, but if there are some network issues, then you will be happy to have some more CPU power to actually deal with these issues. 60 gigabytes of memory are, in my opinion, a must to run on mainnet. Everything below that, it's already a pain. 2 terabyte SSD. I want to emphasize SSD here. Old HDDs, they don't work well with nodes, also not with full nodes, like, and especially not with archive nodes. 2 terabyte might be a little bit on the short side for the long run, as well as too less for some of the clients. We know that some clients don't prune very well, like delete all old data that they don't need anymore. We would, if you want to be like future-proof, then go for 3 or 4 terabytes. That's way better. But 2 terabytes should at least give you a head start and make sure everything runs smoothly in the beginning. Ah, sorry, wrong button. Okay, then, thank you very much. Welcome to David.
Thank you very much. I'm taking over. Thank you. Thank you, Stefan. Okay, as this is a beginner's workshop, we now want to go into the whole staking process. We want to walk you step by step through it because we have enough time. And yeah, so the next point is staking with Ethereum setup. So there are 4 overall steps you have to do for to stake yourself. First of all, yeah, you have to have 32 ETH, but that you already know. Maybe that will change in the future, but at the moment it's 32. Then you have to create your validator keys with a seed phrase. We will show you this today with a tool called Wagyu. Then you should do your validator setup, so a full node run with a validator that you can do with Ethereum, but there are other tools as well. Then afterwards, if you have a running setup, you should load up a validator key with the 32 ETH. And of course, always should start with testnet if you're new to the stuff. And the 4th step is then afterwards, enjoy the journey. Okay. So I try to emphasize the whole process again in a picture. So you create here the key. Then after you have a running setup, then you in that key you you give the withdrawal address where the 32 ETH you will be sent back, and where the attestation rewards and the Syncomedy rewards will also be sent in which wallet. So it's kind of safe after you load it up with the 32 ETH, because if you ever exit your validator key, it will only go to that wallet. So yeah, you're safe afterwards. Then you yeah, after that process, after you loaded up the key, you have some time to be after you deposited the 32 ETH, you have some time to be approved on mainnet. That's, I think, around 7 days. And in the meantime, you can start the validator client and set the fee recipient address. So that's another possibility to earn rewards. And there you get the and the fee recipient is a wallet where you get the block production rewards. Okay. So, how now to create a validator key? You might be interested. There are different tools we will use today, Wagyu, and maybe, as I will show you, you shouldn't do it because you should do it on an extra machine, best set up only for creating a key with no internet connection whatsoever. But for today, as we do it only for test, I will show you on that. So Wagyu is an open source tool. I think you can easily find. As I said, if you're a beginner, you should use the testnet for staking Holeski. Is really pleasant to use. And then, first of all, you need to create a new recovery phase. And as you see, the tool already warns me that the internet is connected. So you should really emphasize on that. So you see, it's really easy to do. Just create a secret recovery phase, and then, like every seed phrase, you should write it down, put it in steel, so that you can't lose it, and never ever share it with anyone except your wife. Okay. Takes up to 30 seconds or longer. Yeah.
Sorry, Mark, someone already asked this. Would it be possible to adjust the lights in the room to make it a little bit...
Okay, yeah. Could we? Oh, yeah. That's hacker tools. They're only always dark mode. So. But maybe that's also securing the seed phrase in some kind. Okay. After you have written it down, you have also here the option to copy it into a file. As I said, I wouldn't store it on any digital device. I would really craft it in paper or in steel. But I will copy it now for the ease of the process. Thank you. Thank you. Everybody, yeah, I wouldn't now go back because then we have to do a next seed phrase, but I think from now on we're good. Okay, so then you go next. It really asks you again if you backed it up. I'm sure that I'm lying. No, then you have to confirm that you have this secret recovery phase. So this tool is really. Now you can check it, and you can use your seed phrase for generating more than one key. And what's the cool thing is you can also generate it to generate further key if you are in need on a later time. So just remember the seed phrase, put it in here again, and then you can already say how much keys you already created and the number of new keys you have. Yeah, it's so I set the password. And if you're a withdrawal address, you might want to take your own one. Perfect. Already some Holeski Eve here. Okay. Take a password that is longer than 8 characters. And remember it. Better write it maybe also down. So, and then you're done. Just have to say where to put the files. I will give it there and create them. And I should have created an own folder. Okay, that might take some time, and in the meantime, yeah, we done the setup. You can also see it in the slides. The QR code is shared, I think, afterwards. So there's the whole tutorial again. And we're done with creating the validator key, so the next thing is to doing the setup, the validator setup. Okay? Yes, here. No, yes. So I'm done. Yeah, you get two files. The one is the deposit file you will use to load up the validator key. I will show you, or I will walk you through the process as well as there. I walk you there. We will use Launchpad for that later on. Okay, lights are, and now we are starting to use Ethereum and making our node setup. So what you need is you need a Ubuntu server machine that runs on the newest Ubuntu version, stable version. You might also use other Linux distributions, but it's not tested, so we can't guarantee you anything. So yeah, then just give in to the credentials, and if you give the credentials the first time, there's this option to save it with the plus sign, and then connect. And of course, first load down the Ethereum launcher, which you can find on our website or in the GitHub. So let's see. Okay, and now you can see how really easy it is to set up a Ethereum node. Because we have this one-click installation, but of course, if you want to do something more fancier or expert, you can do your custom installation, or even you can export a configuration after you have set up an Ethereum node with Ethereum and then import it there. So you can, but we will go up for the beginner session today with the one-click installation. Okay, we have the first step is to select the network. We support, of course, Ethereum mainnet and both testnets, Sepolia and Holesky. And we also support Gnosis mainnet. So you might want to start staking with Gnosis. So it gives you also a good feeling and works exactly the same or very similar. So we are starting with a Holesky testnet today. And now you have different options. You just can set it up as a staking node. That's the vanilla staking setup everybody is talking. If we are talking about staking, there's also the option to do a math boosted version. So you have a client installed that helps you to connect to relays that will help you to math boost, so that's a maximum extractable value. So the block building is done by relays, and you get a little bit more of rewards because a whole entity is a little bit faster than probably how you set up the block yourself. Then we already talked, and if you afterwards have question to it, we can show you a DVT setup. So that's where the key is split into 4 parts, or more than 4 parts, and every entity is staking and syncing and agreeing on their work, and then it is deployed to the network. So it's kind of safe, and not every not every node in this have to be up all the time. So you're a little bit risk-freer and not so reliant on the uptime. Yeah, we have an own setup for Ethereum on ARM, as we said, for Raspberry Pi or a little bit better machines. It's a little bit of an experimental stuff, but try it if you want to. It worked quite well. Then you have the archive node, fully set up. And then we support protocols like the Lido DVT protocol, where you can do node operations for Lido, emphasizing the DVT protocol. So you get 1 share of a key and do node operation and securing and do staking for Lido. And what's quite new and starting in early adoption phase on mainnet is the CSM, the community staking module, where there is some kind of bond. You just have to add a bond and create the keys, and Lido will load your key with 32 ETH, and then you get parts of the rewards, or shares of the rewards, which is quite good. Yeah. So I will take now the vanilla staking. It's always possible to add stuff in the expert mode, so we can show you afterwards if you want to go from staking to MAV boosted, for example. I will show you afterwards. So, and after you made your decisions, you're almost set completely. What you now, as we before said, we are client averse, so their setup is chosen randomly. I mean, yeah, it chose randomly Geth, which you shouldn't use, because I mean, it's running good, but it's the mainly adopted client. And yeah, for decentralized reasons, we should take something else. So you just click on it and choose something else, for example, Bezo. And you can do the same thing for the consensus client. So yeah, instead of Prism, I can use Lodestar. And the validator client is set as well. Normally, you set up your Ethereum staking node with consensus and validator client from the same developer. Yeah, and there are other services installed as well that visualize what is happening in your node. So, and after you click next, you only have to choose a checkpoint sync, which is we have pre-selected sources that we know work quite well, but you're also able to sync with your own checkpoint if you want to. So you can use a custom source. And yeah, that's only an overview where the things are stored or installed, and then you can press next. Okay, in the meanwhile, while everything is setting up, what you will see in a moment, I will shortly tell you a little bit about Launchpad. So if you have created your validator key and if you have your setup ready, then you want to load up your validator key with 32 ETH. And for beginners, we would we would recommend you to use it from the launchpad from the Ethereum Foundation. And there's a really easy setup. You have to choose which net in the first place. So I'm using Holeski, and then it will really walk you to everything. It makes a lot of it explains everything again. It makes a lot of checks if everything is set up correctly. It warns you. I think it's a very nice way just to memorize everything again and deep dive into staking again. But you might as well click through it. But it's really, yeah, I would recommend you to read a little bit into it. It also tells you about the risks, the early adopter risks, etc. There's a checklist involved, so there's really some cool stuff. And then in the end, you confirm. Yeah, and then you can choose even your execution client. We set up Bezo. And get the documentation. Then we took consensus client Lodestar. Yeah, right. It's a kind of optional. What you choose there, then the number of validators. Then you set the withdrawal address. We already talked to. It should be the same as in your key files. Yeah, what's your current operating system? Yeah, and then download the Keychain GUI app we already used, so it's also recommended from the Ethereum. Oh, no, come on. There you can find it also, so that's probably something good. Yeah, and I'm keeping my keys safe. And now you can get your deposit file. And Keychain is very user-friendly, so it already tells you which file to use. So you use the deposit file, open it up, every information is stored there correctly, and continue. And everything you then have to do is, yeah, connect your wallet. Of course, probably if you're doing the real thing, you should connect with a hardware wallet. But you as well might use MetaMask. I don't have now 32 Holeski ETH, so I will finish here. But you then press continue, and everything is set up for you. Okay, so now look back to the Ethereum launcher, and we see everything has started running. And at that point, I think I will hand over to David.
Hi. Okay, nice. Thank you, David. I'm also David, so it's pretty easy to remember. I'm gonna show you basically we are going to. I'm gonna show you how the staking page works. I'm gonna show you the rest of the setup itself. I'm gonna show you some management options. At the end, I'm gonna ask Martin to join me for some questions. You can ask whatever you want about staking. You can also ask me personal questions, but I would refrain from that. Let's just see, as David already explained, basically you deposit your key. As soon as you deposited your key, this key goes into activation queue. Usually it takes a few days. During this time you can already, if you want to, import this key in the setup itself. So to do this, you would go on the staking page. On the bottom, as you can see, there's a click to insert the key. As soon as the key, you basically click this, you select the key itself. I cannot read this, I'm a little blind, I'm sorry. You basically select the JSON key file, you go into Öffnen, and then you would basically go through the other steps. As I can see, we have a little bit of a thing here. What did you use as password? Okay, that's a good password, thank you. I'm gonna go here, bam, bam. On the bottom, as you can see, you're already like inserting the key. On the bottom, you can select which validator client you want to import to. Ethereum gives you the option to run multiple clients at the same time. When it comes to validator clients, I would ask you, or like, please, please, if you run 2 validator clients, never import the same key in both clients, you're gonna get slashed. That's just how it is. Slashing is, especially here, usually not that much of a problem. I know a lot of people like are really intimidated by the idea of getting slashed, but it's usually really rare. Most people you see getting slashed, or if you see someone getting slashed, it is because they thought they were too smart or wanted to like build a backup system that got online suddenly, or tried to like do some great engineering stuff. I can tell you, when you want to stake, keep it simple. Even if you go offline, okay? Let's say you go offline for 1 hour, you will get back the rewards basically you lost in this 1 hour in 1 hour. So it's around the same time. And if you get slashed, there's no, this happens basically immediately. So there's no good, you cannot recover from this. So keep it simple. Try to like stay with 1 client pair if you especially if you're a beginner, and don't go for multiple validator clients. If you want to do a backup system, you can do this by like running a extra execution and consensus client pair. You basically just change the connections. I will show you this after as well. You can do this inside of the UI as well. So we just select here the client we want to import into. In this case, let's see if I get the password correctly. 1 second. So put in the password, you can see, you click there. Then you have the option to import with a slashing protection database. At the beginning, when you first set up, you don't have a slashing protection database. You get this if you remove a key from a validator client. You have the option to download this slashing protection database. As you might like guess from the name, it's supposed to be an extra layer on top of this. You also have the doppelganger protection running. This is basically every client, as soon as you import a key, basically checks the chain if the validator key attested in the last 2 epochs. This can take, depending on client, actually quite long. I think Teku is the longest. I think it could sometimes take up to half an hour. Some of them are really fast doing it. If you have like, if you're in a hurry, you can always deactivate this. I will also show you how to do this. In this case, as I said, we don't have a slashing protection database, so we're just going to import it here. And basically, it's just going to run through. I hope I did did the password correctly. And as soon as this is done, it's going to just it's just going to be imported. You can do this before the activation queue runs. Yes, perfect. You can do this before the key is through the activation queue, meaning as soon as you went through the activation queue, you're already online. So you basically just import it, wait till it's activated. It's just going to be automatically online, and then you are basically attesting. On the staking page itself, as I said, I want to go through some other features, like some management features. On the staking page itself, you have the option to like just open Beacon chart at the end. It's just a quick link. It's the most common used tool to get like a network view on your node or on your key. Because this case, you have a node. It's a peer-to-peer network. Okay, it's not seen. It's not seen everywhere. The Beacon chart basically gives you like a good overview of how the network sees your key. You can also copy the public key, basically identifier, quite common. I think everyone here knows what a public key is. You can give the validator key a name. This name is, if you have multiple friends, you all want to stake on one node, you can give this one name. Let's say you have two keys. You give one. You can name one like your name. You can name one the other. It's just like some management options. You can set a block fee recipient for individual key. There's also the option. Usually, what you do is set up a default fee recipient in the validator node client settings. But if you don't want to use this, as I said, if you have multiple key, maybe you stake with a friend to get on one machine, you can like set it up in a way that your block fee recipient for your key, so your block production reward for your key is sent to your address, and the block fee reward from your friend's keys to send to their address. Then you can always remove the client validator, always remove the validator key, and you can also easily like exit and withdraw. Just click this button. It sends it creates an exit message, gives it to the consensus client. Consensus client broadcasts it to the network, and it's basically it. It's already exited. You then go through the exit queue. Also takes a while. So if you have like huge swings in the value or price of ETH, you might wanna. It's hard to like plan ahead in this case, but you won't be able to like instantly sell it or something like this. So keep this in mind, please. You also have the option, as I said, this is for the individual key. You can do the same for the whole client. So you can set a blockchain graffiti actually. Whenever your node produces a block, you have the option to like include a small message in there. This could be anything. It should be up to 32 letters actually. In this case, what we usually do is set it as default Ethereum.net. It's also basically, if you go on BeaconChart.dn and you put in like Ethereum.net, you will see how many blocks were produced by people who are using Ethereum and didn't change that. As I said, you can change this whenever you want. It's nice for us to have like some numbers, but if you just want to like have a fun message in it, it's absolutely fine. Also, the option to remove for all every single validator key from the client. Option to withdraw every single validator key from the client. And as you can see, there's also the option to import remote keys. We support Web3 Signer. I can say personally, I don't use it, and I don't think any one of us uses it. Because with this, it's basically really easy to switch between the client pairs anyway. What people usually use the Web3 signer for is like they use this as an extra layer so they can import the keys into the validator client, and it's just switch it up. But if you want to do this, it's just click. You can show this off. It's just a click. You can do a local one. You can also like choose an external one if you want to. So if you have the Web3 signer on an extra machine, you can just put in the URL to the machine itself. On the right side, you see a little bit of some stats. As you can see the epoch. You can see the slots, the current slots. On the bottom, if you would be part of the sync committee, or you would be part of the block production, is like going to be soon. You will see this on here. This is basically like an extra help for you to know when you have to do updates, because block production is kind of rare. It's basically once the chance to do this is 1 in 150 days. So you get it on average twice a year. Some people are more lucky, some people are less lucky. It's basically a lottery on top of the attestation rewards you get anyway. So you also have the option to group these. So if you have, like, as I said, if you have friends or you have multiple, or you do some staking for other people, you can group their keys as well. You would basically click here, then click here. You can filter the clients. This works with public keys and the names you can set. And you can also just switch between the showing the names and the public keys. So now we're gonna go a little bit into the node page. It's probably a little bit more exciting. Ethereum supports you having actually multiple configs at once, or we call them as setups. meaning you could, in theory, run a Holesky node and a mainnet node on the same machine, given your machine is strong enough. They obviously need still the resources they need. In this case, we only have one setup. David just set up. It's basically setup 1, where we can go in. You see the 3 client pairs. Bezo is already syncing. Loadstar is already synced with the checkpoint sync. And you can see also, like the VC has here, it's 1 key. What you usually would do after going through the setup is also set up a default fee recipient, because you need this. If you don't set the default fee recipient and you produce a block, you're gonna burn your block reward basically, which is nice for everyone else. They're like happy about like losing some ETH in the network, but for yourself, you're gonna like bite yourself in the ass basically, because as I said, 1 in 150 days. Especially if you use Math Boost, this could be quite some money. We ourselves like produce blocks. They are like multiple hundreds of ETH. Obviously, usually it just happens when we have like a hack on the network and some hacker sends it like as fast as he can. It doesn't care about the priority fee at all. You would basically get this if you send it back. That's like I guess your decision. I never like got the process quite. But what you would do is you would go in here. You see here default fee recipient. You would just replace this OX000 address. Then you would confirm and restart. You can see we can set a gas limit here. This is actually important. The current discussion like to set this higher and lower. Then we have the double ganger protection. As I said, the double ganger protection is supposed to protect you from slashing yourself, also getting slashed through the keys is like just an extra layer. If you would import, and it like detects that you tested in the last 2 epochs, it will basically just give you a warning, hey, are you sure you want to import this? Obviously you can still import it, but usually it's a pretty good warning. You should probably keep that in mind. If you don't want to wait, also as I said, some clients really need long. Like if you're in a hurry, there is usually no real reason to do it, but if you're really in a hurry or like have multiple hundreds of keys, you can always like deactivate this, also just confirm and restart, and then it would just like import it without doing this check. As you can see, also really interesting. We built the whole thing in a way that you're capable of like seeing what it does actually, if there's like a small task manager. So you can always just, if you run into like any error, for example, could be it's a client software, it's in development. Usually, like sometimes they're stable one release, sometimes they get unstable the next release, then they get stable again. It's nice, obviously, that they get still like this that much like development time, but this could lead to always like some problems during the version. If you run into a problem, we usually recommend you to just check out first if in the task manager you can copy this data. You can come out on our Discord, you just copy it in if it's an error. You can always also go in for the clients themselves. You can always go into the log pages. The log pages are basically your bread and butter when it comes to maintenance. Whenever you run into any problem with the clients themselves, you will basically find this in here. You can switch through the clients themselves. In this case, as you can see, we're already like syncing here on Loadstar is here syncing. It just tells you the errors happen quite rarely. Usually, the node usually only breaks if you have like a blackout, for example, or you run into any like syncing problems. If you run into syncing problems, we have easy command to do this. You can always go into the resync button. It's basically the same as the thing in the setup themselves. You can, if you want to sync from Genesis, I don't recommend this. It's also not recommended by the client teams to do that, because A, it takes forever, and B, you just sometimes you could run into problems during the syncing from Genesis. Then you can you would just select like a checkpoint sync, recommended one. You go with, for example, Lodestar or something like that, and it basically just deletes the old database and attempts to sync from this checkpoint itself. Some other things we have like a link to the documentation. So if you're interested to like configure your node a little bit more deeply, maybe you use it for development. We do this. We have like the option in Ethereum. You can in the settings themselves, you can go into the expert mode. It's basically Docker compose config, a little bit of a glorified one. You can see, you can like set up the options here. We give you the full control. But if you play with this and you break your node, you basically, I think you know what, we hope that you know what to do. That's why we call it expert mode. You can like add from the documentation some stuff. If you need like, for example, longer block retention, you want to change some like parameters, you need different namespaces for development, or want to get different data, you can do this, basically set this up in there. Then the next one, we have like a simple start and restart button, pretty basic. And from this is basically the node page. What David explained to you also is you can go with a MEF boost. It's really easy to set up. So this is now a solo vanilla staking one. If you, let's say, you decide after like a week of running this, hey, actually I want to use MEF boost. You don't have to set up the whole node again. You just go in here. We have like a edit node page. You would go in here. As you can see, this is you can see here the connections. You can also change these connections. On the right side, you have the option to just add stuff like MEV boost. Oh, okay. You can choose the installation path. Then you would go next. You choose your relays. These are obviously different on mainnet, and they are depending on the network you're currently on. You can take all of them. There's usually no reason to not take all of them because MEV boost takes the best block from these relays. It just chooses this automatically. If you're American, you might want to go with the OFAC compliant one. I don't know how. I'm not an American. I don't know what happens if you don't. I'm really honest. But just gonna go with all of them. Then you would go next. You have to connect this to a consensus client. You can only connect the MEV boost to one consensus client. If you want more MEV, if you have more consensus clients, and you have to add more MEV boost services. Then we go with Lodestar. We confirm, and as soon as we confirm the changes here, it basically is going to install this. It's going to connect all of this, and then your node basically chooses, or your consensus client chooses, if usually the MEV boosted block first, the one that's suggested by MEV boost. If it's not fast enough to do this, it will just take the one that's actually provided by its own execution client. As you see, you have like the small like little icon here to indicate that you are like connected with this. You can always change these connections inside of this. So let's say if I wanted to add another consensus client, like Lighthouse, okay. Like Lighthouse, it's the same path. You choose the installation path. You choose the sync options. In here, we can also go for like just checkpoint sync. As I said, I would recommend this to use this always. Client teams recommend you to always use this if you don't need the data itself. You go next. You can connect this with execution clients. If I had more than one execution client, I could basically choose this in here as well. In this case, I'm gonna just go with the basic one. It's the same thing, I just confirm the change. And after this, I'm gonna show you how to modify the connections, meaning let's say Lodestar would fall out for some reason, could happen. Then I could like pretty simply switch to using Lighthouse with like 2 clicks of a button. See, I'm gonna go in here. I can obviously also delete this. I can switch the client itself out. Usually don't recommend doing this either because you have to do some config changes as well. So if you're an expert, you probably could use this. If you're a beginner, delete it and just edit new. It's basically the same time. It doesn't like take any longer. You can go here into the modification, and just as you can see, if I wanted to change this, I can just go here, and now it's, as soon as I've confirmed the changes here, it uses the Lighthouse client instead of the Lodestar one. So you can build multiple client pairs if you have the storage and the resources on the server itself. You can build multiple client pairs, run them on parallel, and then just switch between them. You can do this over multiple nodes. You can also multiple servers. I can show you this in a second as well, as soon as we are through this. Takes a little bit. We have like the option to make this a little bit easier. So you would go in here, you can go here for external, if you can write it, external here. You will set up our external source. There's a little bit of a difference between the clients. All of them are the same except Prism. For Prism you have to set the extra value, though this is gonna change soon as well. So soon this is not gonna be a client selection anymore, this is gonna be agnostic. The external source, you would basically set up a IP, like a server IP with the port. You could go in here, just set it up. I'm just gonna put something in there. Doesn't matter. It's basically like a placeholder you then can connect your client with. Meaning, if I had another machine with another IP, with another with a port to access the client inside of my network, I could run multiple servers. I could run multiple client pairs on one server. I can run an execution client on one server. I can run a consensus client on another, a validator client on another, and just connect them through this, and then just switch depending on actually my own needs in this case. Also, again, takes a little bit, but it's quite fast. So if I wanted to now use the external one, I would go the same way, go in here, select the external one, confirm, and then just go further. So David talked a little bit about using the node export option. You can, if you run the setup, you would just click here. It would basically give you this one setup. Let's say you want to migrate your node, you have a new machine, okay, and you're a little bit lazy. You can. It also doesn't take that much longer, but you could just click here. You would download a zip file with the configs. You would go into the setup again, and then you can just with the import config option just import this zip file, and then it just sets up what you had before. You obviously have to import the key again because we don't have your password. We don't like store any data. You don't send any data. This is like pure your stuff. And you also have the option to like import like a single config. This would import all of them, export all of them. As you can also see, we use Grafana and Prometheus. We have like a nice little control page. It's basically, it just gives you a basic view with really simple stats. If you want to go more complicated, you can always build your own Grafana dashboards if you want to. We deliver the client Grafana dashboards with them. They are basically default to use. You can set the alerts in Grafana. You can like actually like get some external notification going on in there. You can see you have here the current sync status. Now it loads like your node's view on the network. Usually I don't recommend taking this as how should I say, as the most source of truth when it comes to like the network status, because it's just your own node's view on the network. If you want to actually know the network status, please like visit beaconchart.in, great tool. You can see on the right side you can use your RPC provider. Because Ethereum uses SSH to connect from your launcher to your server. You have to open the tunnel here. Then you can copy this string. We'll put this, for example, into MetaMask. I could show this. You would take this one, you could go in here, you have like the network option. If you go in here, you go in here, you can go in here. You should go, where is it? I haven't done this in a while, I have to be honest. You would basically go into the options themselves. Okay. You would just put this for the RPC connection, you would put the ETH symbol, you would choose a blockchain explorer to basically show you the transactions and how they are used. Can you go back? Das ist schon zu retarded für you. Ja, es geht zurück, bitte. Okay. Then you obviously also have the WebSocket endpoint and the data API. This one is from the, this is provided by the execution client, the RPC. The WebSocket and the data API is provided by the consensus client. If you run multiple ones, you can switch through them. You can also see here a little bit of stats from the key client themselves. Some of these are currently a little bit, these are currently wrong because your key obviously didn't like start the testing and it didn't go to the keys, to the queue itself. When it comes to updating, because you constantly having a node is mainly maintenance. Maintenance is really, really easy with Ethereum itself. You have two options to do this. You just, as soon as there's upcoming hard fork, for example, you would just go in here and you can update like your clients. You have multiple update options. You can go with your server OS updates. You can, Ethereum consists of two parts, the launcher and the node. So if there's a new Ethereum release, you will have a new launcher version. This usually happens as soon as you open Ethereum. It's going to go into auto update mode. It just downloads the newest launcher version automatically. You would then log in, go into the node updates, could just download it here. If there is a service update, let's say GAF has a new version, you would see it in here. You could just click it. You can just also update all at once, except the server OS updates. They're on an extra page for good reasons, because it probably is going to restart your node. A lot of people don't want to do that. If you are really interested, we have a lot of people who actually, Ethereum provides you with the option inside of the server management page. You can switch through the servers here as well. As you can see, we have multiple ones. You can also change your password here. You can set up, you can create SSH key. You can delete SSH keys here. You can manage these as well. And you can do the Ubuntu updates here. Just gonna check for them. It's gonna find some. Nope. But with Ethereum, you have the option to always go with the automated node updates. These are actually gonna pull down all the Ethereum node updates and the client updates. We have a lot of users who put this on and then never look at it again. Works quite fine. We also have like some nodes where we have this open. They still attest to this day. So even if you're on your way, let's say you travel a lot, this is like an easy option to actually check your nodes. You can and automatically update it without having to constantly look into it. We also have an experimental 2FA feature. To use this, please do actually these. There's still some problems with it that we are currently working on. You also have the option to like just add a new server connection here. You can switch through them. If you have a SSH key set up, you can actually go with a quick switch, which is really, really nice. Then with this is the update process. If you're a little bit of an expert, we have the option for you to go into a secure shell. So you can actually also use this here. You don't constantly have to switch between terminal and Ethereum. It's just for us. We built this especially for us because it gets annoying after a while. Then you also have here on top a help button. So if you need any help, you can go from here. We have like a GitHub, obviously, open GitHub. So if you find any mistakes, please be so kind and just report them. And we also have a documentation itself. We also have the option for the notification. We support two things. We have like a small little mobile app. It's really, really small. You basically set up a Grafana alert. This comes over encrypted over relay to us, and we will send this out. But you also have the option for the more common, what most people use is beacon chart.dn. It's not hard to set up. You basically click here, then you would select your validator client here, set the machine and the API key up. You have to set the API key on the beacon chart.dn website itself. Then the updates are already showed. And you have also the settings. You can change some languages. We translated as much as we can. So if you are not an English speaker or know someone who is not quite that much of an English speaker, you can also use this. And yeah. The option, maybe if you run into problems, what we usually do, or I at least usually do, if there's like something breaking my node, I'm a all or nothing kind of guy. I like to just nuke the node. We just basically press here, and this kills the whole thing. You can dump your logs here as well, and as soon as I click this, it's just gonna delete everything on there. It takes a little bit. It's quite a nice animation. You can thank that guy here for that. Just takes a little bit. I'm gonna then show you some of the other options we have as well. Like just go through them one by one, and then I guess in 5 minutes, if you have like some questions, I would love to answer them all. So just get down to this node again. This is now a nuked node, meaning as soon as I go in here, I go basically through the whole process again. It's just gonna check is there a node installed. If there is no node installed, I'm just gonna go through this page again. The options are pretty simple. In this case, I don't have much time, sadly, to show you the other stuff. If you're interested, we can always talk about it. But the basic difference is this installs extra validator client. SSV uses not the standard validator client. They use their own validator client to do this. Obol uses an extra service that is connected to your validator client. So if you go in here, you would see in here, this installs the Obol Sharon service. Then the Ethereum on ARM, you can basically, this is installing just the node clients without monitoring services. The archive node usually just sets extra stuff in your expert mode config, so you actually retain the blockchain data. And the Lido SDVTM modules both use SSV or Obol respectively. And in the end, we also have the Lido CSM itself, where we have the validator ejector Lido uses, we have the Lido Keys API and the CSM monitoring service we built for this, as well as an IPFS service to just keep the data for a while. So, okay. With this, I would say we have 15 minutes left. I would love if any of you guys have any questions. We're gonna answer them all. Martin is gonna help me with more technical questions. It's not quite my forte. So.
Hi. When you use this installer for ARM devices, when you would like to deploy an Ethereum node on ARM devices, because you have very limited resources, for example, on Raspberry Pi 5, I guess you have limited options about execution and consensus clients, and I'm curious which one you recommend or which one you use as default.
So I actually set that up quite a while ago. That was back in Gurley, and what I used was Geth and Nimbus. Nimbus is very lightweight, and especially if you run on these small devices running on ARM, I would recommend Nimbus for these kind of cases. But It depends. It really depends. This machine was like even a smaller spec. It had like only 4 gigabytes of RAM, and it took like 2 months to sync. 2 months, 2 weeks to sync. So probably not the best. But if you're like have a bigger device, you can have like more options open. Maybe even Nethermind, or like depending. Would have them to experiment with all the settings Ethereum provides you, or the different clients. Nethermind, for example, runs great, but if it comes to pruning, you will probably have to reduce the used load while pruning. But yeah, and it is possible. You're limited, but it's definitely possible.
One more question about path to the storage, this 2 terabyte drive. When I would like to use 2 drives, one for operating system and the second one for the blockchain copy, can I provide a path where the blockchain should be stored?
If the partition is correctly mounted, this is definitely possible. Ethereum will check your partitions and will use the biggest one out of default. But you can change it up the way you want.
Okay, thank you.
Do we have another question? Okay. So.
Hi. So thanks for the presentation. Quick, idea. If let's say you have more than one validator key, or sorry, you want to run more than one. The terminology eludes me a bit, but let's say you've got 64 ETH, you want to run 2 validators. Is it best practice to run it on 2 separate, completely separate things, or is it best practice just to use one sort of setup for both keys?
I would. So the validator client can, in theory, hold infinite validator keys. I usually. The more validator keys you import into the client, the more resources it will use to basically sign for them, because it like has to sign and then send this to the consensus client. But you will not notice this until you have like 100 keys on one node, which is quite rare for some people for obvious reasons. So I would recommend you actually to use one machine, because you run. The problem is, your biggest risk is the slashing risk, and if you, for example, forget which key you imported in which client, you could always, like, a human error is your biggest enemy, basically. So having them on the same machine is probably like the best way to go in this case. And
one quick follow-up to that,
yes,
then.
please.
By running 2 validators on the same client, are you running a risk of both being slashed at the same time? Or it would only be one or the other in most cases?
So you don't really run if you just have one validator client and you only have these 2 keys in this one client, there's no risk of getting slashed whatsoever. The risk of getting slashed is, for example, if you have both as you described your scenario, if you have both of these nodes running, okay, and for some reason you forget which key you had on which client, and you import this again, okay, it's gonna warn you, okay, it's gonna tell you, hey, the doppelganger protection is gonna say, hey, you are like testing the last 2 epochs. But if you just like mindlessly click through this, okay, you're gonna get slashed just by having the key in 2 different validators clients active at the same time. Otherwise, slashing is basically, it's a really rare event, and it's actually really hard to like actually run into if you don't try to, as I said, be smart about it, or try to some backup setups or something like that.
If I may make just one other scenario quickly.
Yes.
So in certain parts of the world, let's say Southeast Asia, power outages are somewhat common. You know, I'm worried about my machine running. We lose power. It doesn't reboot properly. You know, in such a case, if you've got both of your keys on the same validator, then both would be slashed for being offline. Is that correct?
No. Slashing is never for offline. Slashing is really just the penalty you get for trying to cheat the network. In this case, if you try to, as I described, sign with the same key on 2 different validator clients.
Yeah.
What you run into with getting offline is leaking, which is basically node goes offline for, let's say, your node goes offline for 24 hours, for example, or 84, 48 hours, 72 hours. There is no real risk for you to just like actually set this up again. If you don't get stressed about it, okay, you're gonna, if you lost in the 72 hours as penalty, you will get back in 72 hours. So there's really no risk as long as you don't try to, as I said, build backup system. There's a way to overcomplicate it and go online at the same time. You will never run into slashing. Yeah, you're welcome. Right. What do you need when staking with LiDAR CSM? Yeah, that's a good question actually. LiDAR CSM, you basically go through the same process David showed you. The only difference is instead of the Ethereum launchpad, you go to the LiDAR CSM launchpad. There's like a test LiDAR CSM. I could probably share this before. Maybe we can probably can show this after, or like I'm just gonna like if someone's interested, just come to me. I can share you the link with you. You take the empty key, you go to the LiDAR CSM page, you upload the key in there, you pay your bond, and that's basically it, and then you just import the key. It's the same process, as I said, just instead of the launchpad, you go to the LiDAR CSM stuff. How many people use Ethereum? It's really, really hard to say. We don't collect any like user data. We are not interested in your user data. We don't want that. The best indicator we would have is actually, as I said, the blockchain graffiti. You only like see when the validator key actually gets to produce a block, which is 1 in 150 days. You could see, you could estimate it. I would probably say around 1,000, 1,500 based on the download numbers. But I also have to say we have a lot of, because the tool makes it a little bit, maybe even too easy, we have a lot of lazy users who don't do the updates all the time. They just, like as I said, put the auto update on. It's gonna like get the client down updates automatically. It's gonna take the node updates automatically. So they never show in our like actual download numbers from GitHub. And this is really the only thing, the GitHub numbers and the blockchain graffiti we can use to estimate that. Are there guides or tutorials for Ethereum? Yes, we have like a documentation page with like guides. We also have like a little bit old tutorial videos, but they basically still work the same. The UI changed a little bit between this. Maybe interesting to see what we did in the years we working on this. So you also can always come if you run into any problems whatsoever. We have a Discord server. We are 24/7 there. Basically, when they don't sleep, most of us are Europe-based. So if you write to us at like 3 AM at Europe time, we might not like answer directly. But as soon as we wake up, we're gonna see your message in our Discord, and to just come and actually try to help you. There was never a problem we couldn't fix. Really, as long as you like actually give us all the information we ask for, and you just communicate with each other, it's really, really easy to go through most problems. And yeah, if there's no other question, I would like end it a little bit early, if that's fine for you guys. So anyone else, anything? Okay, perfectly. I don't know, thank you everyone for listening. Thank you for your attention. If you have other questions, like personal question or like a specific question to like set up, you can just find us. We also have like a booth on Thursday and Friday. You can try it out yourself if you want to. We have like machines here to actually try it out. We also have some nice merch if you want to come here. And yeah, thank you very much. And I hope you all guys all have a nice day.
Hello, everyone. Well, today we're going to be talking about Waku. Waku is a decentralized protocol for messaging that allows you to send a message from point A to point B in a privacy-preserving way. And RLN, you may have seen it in the title, stands for Rate Limiting Nullifiers and allows you to rate limit the users in a network to prevent spam. So first of all, I would like to introduce you Frank, lead of Waku. He will be presenting the second part, and I will start with an introduction and some small workshop where I will show you how to join the Waku network by running a node and participating in our network. So this is the agenda for today. I will start with a Waku introduction, telling you what Waku is, what Waku is not, the future, the problems we have already solved in the past years. Then we will continue with the small demo that I told you before. It's going to be a quick workshop. I will share the commands with you in case you want to run them and in case you want to become an operator in the Waku network and relay traffic on it. And then Frank will talk about the need for a flexible rate limit in RLN and the economics behind Waku. So before explaining what Waku is, can you guys raise hands? Who knows what Whisper is? Okay, I see a bunch of hands up. I think I know everyone. Okay, so Waku is some kind of fork of Whisper, and it fixes most of the problems that Whisper had originally back in 2016, 17, something like that. So yeah, Waku right now is a suite of messaging protocols. And it's meant to deliver, as I said before, a message from point A to point B, or from point A to multiple points, like a group, for example, a group chat. It does so in a privacy-preserving way, without relying on a central entity. And it's generalized for any use case. You can build a chat application, but you can also build any decentralized application that you can think of. If you need to connect, as I said before, point A with point B, with these properties, you can use Waku. So we are not really binded to a specific use case. And yeah, the coolest thing is that it's permissionless for anyone. Anyone can join the network. So as I said before, Whisper had some problems, and Waku has solved most of them in the last years. First of all, latency. So in a network with the properties of Waku, latency is very important because the messages don't go directly from point A to point B, right? They travel through many nodes, jumping multiple times, right? So to fix this, we have limited the message size to 150 kilobytes. I will explain later why. And yeah, for the latency, there is also a trade-off between the replication factor and the bandwidth. I will explain this later. But yeah, long story short, we can guarantee to some extent that every message in the network will arrive within one second. Second problem that we have solved is the rate limiting. So in the Web 2 world, it's very typical to rate limit with an IP, right? So if I see that your IP is sending more than X requests per second, I will stop you, right? Because you are not making a fair usage of the resources. But in the Web 3 world, it's a bit more different because Waku, in the Web 3 world, it's a bit more different because you don't have an IP to rate limit because you can't connect the messages to an IP. So we are using RLN, which stands for Rate Limiting Nullifiers. This was originally designed by the Ethereum Foundation, the PSE group, and we have adapted it. We have also some peer scoring. So to every peer in the network that you connect to, you keep assigning a score. And if the score drops below a given threshold, then we will kick out this peer from the network. So the third problem we have solved is the offline node. So your node could be offline for a few hours, days, minutes, or seconds. And someone may have sent you a message during this offline time. So for this, we have a store protocol and store sync to fetch these messages that you missed while you were offline. So running the fourth problem we have solved is the running Waku in resource-restricted devices because running a full node, as you know, like in Ethereum, right? You can't run a full node in your phone. It will drain the battery and you will run out of memory super fast. So for Waku, we have designed light protocols. They are called filter and light push. These light protocols allows you to use the network and publish a message, for example, on behalf of another peer. This allows you to run Waku in a mobile phone, for example, without consuming battery and data. Yeah, I will be talking about this on-chain Merkle trees a bit later. And yeah, last but not least, we have scalability. We have solved the scalability of the network by sharding the network in multiple shards. So we have split the network in different sub-networks. So I will zoom in each of the previous points that I have explained. Latency, let's start with the diagram on the left. Here we have, in the lower axis, we have the outbound degree D. If anyone knows about Gossip Sub, you will know this D. This is basically the replication factor. So how many times the traffic that you inject into the network is replicated. And on the other axis, we have the amount of hops that a message will travel in the network before arriving to all the peers. So the thing here is that, let's say that you set an N of 1,000 nodes. This is the amount of nodes. This would be the red plot, right? So let's say that you want a replication factor, meaning like the times that you replicate the bandwidth in the network of 6, for example. Then you will have a worst case amount of hops of 4, meaning that a message, after traveling 4 hops, it will arrive to all the peers. So as I said before, there is a trade-off in here between this and this, right? Because you can't have low latency and also low bandwidth consumption. So we were playing with this. So we have done some simulations. You can check them here. This is the distribution times of arrival of a message in the network. We were using different sizes, 2 kilobytes, 25, 100, and 500. And you can see this is the distribution. So in these 3 first plots, you can see that in the worst case, every message arrives within 1 second. This is why we have limited the maximum message size to 150 kilobytes. As you can see in this case, with 500 kilobytes, the average time goes quite up, close to like 1.7 seconds, and this starts to go quite high. So if you send in WhatsApp, it takes less than a second to send a message to your friends, right? So we should strive for something, similar. Cool. Let's continue with the rate limiting. As I said before, we use RLN, rate limiting nullifiers, to rate limit the users. So a rate limit example could be like, okay, we allow a user to send 100 messages every hour. The cool thing about RLN is that it does so in a privacy-preserving way using zero-knowledge proofs. And we can also act upon the rate exceeded. For example, if we detect that a given user has exceeded the rate limit, we can slash him or her. As I said before, this was initially started by the PSE at the Ethereum Foundation. So I will explain more detail about RLN. What does it mean? What is a membership? So basically, a membership, it's your key that allows you to participate in the network. This membership is stored in a Merkle tree that is on-chain, and anyone can register its public key on-chain. You have to only pay a fee. We have deployed it in Ethereum. By now, it's a Sepolia. It's a testnet, which is called Sepolia, but anyone can do it after paying a fee. So yeah, basically, we are storing this in the blockchain. We have this is your leaf. This would be you, and we have a Merkle tree representing all the memberships. Very easy. So the thing about RLN is that only the one who knows the private key of this public key can generate a proof, right? You can see this proof as some kind of a stamp that you will put to a letter. You will stamp to a letter. This stamp is, in reality, a zero-knowledge proof, and it allows every node in the network to verify that the message is correct and is respecting the rate limit. So yeah, it's attached to the message and it makes it valid in the network. You can think of it as a stamp that you have to buy in the post office and put it to your letter. Since the Merkle root of the tree that I showed you before is public, anyone in the network can verify that the message is correct. So you get the root, you get the message, you verify the zero knowledge proof, and you can decide if you want to accept or reject the message. So yeah, offline nodes, basically what I explained before, if your node goes offline for some time, you will have to fetch the messages that you missed. We have two protocols, store and store sync, and yeah, the latter is based in range-based state reconciliation. Regarding resource-restricted devices, we want everyone to be able to use Waku, even if you are running on a mobile phone. So for this, we have these two protocols, light push and filter. Light push allows you to send a message to the network via another node, and filter allows you to receive. You can think of it, we call them light protocols or edge nodes. You can think of them very similar to what Ethereum light clients are. I heard before a talk about the portal network. So this is very similar to that, because we can't assume that people are able to run both Ethereum and Waku in their mobile phones. We have one feature that we deployed to the Waku network quite recently that I think it's worth mentioning. So in order to generate a zero knowledge proof, you need to insert as a witness, if you know about zero knowledge proofs, you have to inject the Merkle proof of your leaf. The thing is that if you are a light client, you don't have this information, right? You would need to synchronize the whole tree locally and then be able to generate the Merkle proof. So long story short, we have done a modification in our contract, and in this contract, now we are storing the whole Merkle tree, and you can get both the Merkle root and Merkle proofs directly from the contract, meaning that a light client or an edge node can go to the contract, get whatever he or she needs, and then generate the proof and send the message to the network. So yeah, as I said before, you can generate proofs without syncing the tree locally. This is very nice because syncing the tree, as you may imagine, you have to synchronize many events, and this can take several minutes. And yeah, you can get the Merkle root and Merkle proofs from the contract, and these calls are gas-free because you are not changing the state of the blockchain. So the cool thing about this is that the gas increase in the membership insertion is very reasonable, so we can deal with it. Waku may move to a layer 2 to make to lower the fees, but even right now the fees are not that crazy. So yeah, RLN, it's working for light protocols. And yeah, scalability, nothing to add to what I said before. We split the network in multiple shards, and right now in the Waku network, we have 8 shards. Basically, if you know about Gossip Sub, we have one topic per shard. Okay, demo time. I hope this wasn't very painful. 15 minutes, not bad. If you are interested in following along, you can scan this QR code. I will leave a few seconds. You can also browse it. It's Waku.org and Waku Compose. Yes, if you have any questions up till here, I can take a few. Yes, in the demo, I will show you. I will show you. Yes, yeah.
Just a quick question. You say you generate a zero-knowledge proof every time someone sends a message, yes?
Correct.
How much time does it take to generate the proofs on average? Any idea?
Yes, we wrote a paper actually about this. It depends on the platform, blah, blah, around from 80 milliseconds to 150 milliseconds, depending if it's a MacBook, a Raspberry Pi, whatever. But yeah, 100 milliseconds, it's a very basic zero-knowledge proof, because it's just proving that you are part of a given Merkle tree and that you respect a given rate limit. It's not like, in Ethereum, they are trying to prove blocks, and this takes like 2 hours, right? But yeah, thanks. Don't be shy. Cool. We will take also questions at the end, so no worries. Cool. So as a good engineer, I don't rely on the internet, so I have a video because I don't trust the internet. So yeah, what we are gonna do now, we are gonna run a Docker Compose setup that runs a Waku node, and we will also show you how to interact with your Waku node with a simple front end. And with this, you will be part of the Waku network, and you will join other nodes relying traffic. So let's start. You can see that the terminal is open on the right side. On the left side, you have the QR code link. We start with copying the configuration, the environmental file. Now we open it, and we have to modify a couple of things. We are using an Ethereum endpoint. You have to provide your Infura API key, for example. You can copy this, it's fine. You have to provide also your Ethereum private key. Do it only for testnet. You can copy this as well. This is the account. This account has to be funded with some Ether in Sepolia. And now we are going to register your RLM membership. This is a transaction that goes on chain to Sepolia and will give you the right to use the Waku network. It takes a few seconds because it's also waiting until the transaction is validated by the nodes. I will show later the fees we are paying for this. You can see also that it will appear here right now. You register your membership for a given rate limit. In this case, we have 100, meaning that you can send 100 messages every 10 minutes is the rate limit that we have defined. But you know, Waku is open source. If you don't like it, you can fork it and have your own rate limit. So yeah, you can see that the credentials are persisted. You can open the key store. It's a key store very similar to the Ethereum one. It's a bit different, but yeah, you can open it, a bunch of hexadecimal numbers. Now, yeah, this is the transaction. This is the smart contract, the RLN smart contract. This transaction is the one that we just submitted. We have 21,000 members in the tree. And I will open the transaction. You can see that the gas, wait 1 second. Yeah, it's consuming 150K of gas. This is quite reasonable, even for Ethereum mainnet. The function that is being called is the register function. This is your commitment. So it's basically the hash of your secret, more or less, and the rate limit, which is 100, as I explained before. Here we configure the store size. I set 1 gigabyte, meaning that I will store only 1 gigabyte of messages. And now we are ready to spin up all the services. This spins up some Grafana and Prometheus dashboards to monitor some metrics, the Waku node, the most important thing, and also a front end that allows you to interact with your node. You can check the logs if you are interested. For now, this is like you don't have to really understand it. And yeah, the first time that you start the node, it will take some time because it has to synchronize the smart contract. It will index all the events until it goes to it reaches the latest head of the blockchain. And once done, your node is ready. You will be relaying traffic of other people. You will have the RLN tree synchronized. Yeah, you can see here, this is the front end, localhost 4000. You can enter your username. And then you can join a group. I suggest if you want to join Devcon group, you can talk with other people. Here you can input your message, and when you click send, it will be sent to everyone that is subscribed to the topic Devcon. You can see that the message is there. Cool, so this was the demo. If you have any problems with this, later when we finish the talk, we can help you if you are interested. Quick note before I pass the mic over to Frank. This is cool, right? But I mean, I have WhatsApp, it works, that's the same. The user interface looks nicer. So why do you care about this? So first of all, you are running a full node, which is cool. You are relying traffic in the network, so you are helping others to communicate with each other. You also store past messages, and you have your own RLM membership. You don't have to rely on anyone. And yeah, with this, you are allowed to use the network up to a rate limit. This is cool, okay. But yeah, what's the advantage of using Waku? So first of all, the messages are not linked to any identity or IP. Every time you send a message, this zero-knowledge proofs doesn't connect your identity to the message. And also, since we are using GossipSub, to some degree, we can guarantee that no one will know your IP or will be able to connect your message to your IP. Also, you are fully sovereign. You don't have to trust anyone in order to use this. And it's decentralized because there is no single point of failure, and you are connected to multiple nodes using GossipSub. And yeah, with this, I will pass the mic over to Frank. He will be speaking about RLM version 2 and the economics of Waku.
Thank you, Alvaro. So, yeah, so RLMv1 is what we actually presented at last Devcon. I've been working on that for a while. And in the past year, we have done several improvements and what we call RLMv2. I've already touched upon the fact that now we have our Merkle tree on chain, which means that you can just do a smart contract call to get your Merkle proof and generate your proofs. Another change that we have is around the rate limit. So as we mentioned, the idea is that you generate a proof and it's attached to an epoch. So an epoch is just a timestamp with a granularity of choice. The first version of RLN, you could only rate limit to one message per epoch, which means that in terms of smallest practical epoch, 1 second would be the best. Under that would be difficult, especially considering network latency. And anything above 1 second, if you go for 10 seconds, 1 minute, then becomes impractical for chat app, right? Because if the user has to wait, 1 minute or 10 minutes to be able to send the next message, not very useful. So also in terms of traffic, so why are we using RLN again? The idea is to rate limit how many messages can the publisher send on the network, so that you can cap the bandwidth on the network, so that when you use Waku on your mobile phone, on your laptop, on your household broadband, you know that you're not going to consume all your data, as well as you know that you can still be part of the network. If let's say you have 10 megabits per second at home, and that's what your internet can support, and someone comes in and injects a terabyte of data, you will not be able to receive all the messages and then forward them, as GossipSub tells you to do, which means that you will misbehave in terms of GossipSub terms, and then you get kicked out from the network. All right. So if we have unlimited bandwidth, there is no capping of the bandwidth on the Waku network or on any GossipSub network, then you may get kicked out, which means that basically you have an outage, you get dust from the network, right? So with Waku, as I've already mentioned, we want to be able to have a decentralized peer-to-peer messaging, but also for laptop and mobile. We don't want people to have to use a centralized REST API. So back to the numbers. So with 1 message per second, and let's say we have a 5 kilobyte message size, so average, and let's say we have 1,000 users. So we think we can go up to 10,000 users on a given shard, but let's say if 10% of the users just continue to message, non-stop, you end up with 5 gigabits per second of steady traffic. So non-stop steady traffic, and you can imagine when you go back to a mobile phone or just having this non-stop traffic on your broadband is a problem. So with RLMv2, like from a technology point of view, the improvement is that now we can do n messages per epoch. So we're able to choose a number, and that allows us to have a wider epoch, right? So in our case, we chose a number of parameters, and we're going to start with that. Of course, we can change them as we learn more, as we use them in various applications. So currently on a smart contract, we went for 20 to 600 messages per 10 minutes. So we went for an epoch of 10 minutes, where we can use 20 to 600 messages. In terms of whether it's 20 or it's 100, it's up to the user. When they insert a membership, they insert a public key to the smart contract, they can decide what rate limit they want to pay for. So we also have a rate limit on the contract. So on the smart contract, we have a parameter which is the total number of messages per epoch. So we set to 160,000 messages per epoch. And on the network layer, so more as a consensus between the operators on the gossip sub layer, we went for 150 kilobyte max message size. So now we have more of an API token-like, all right? So when you go, for example, to Infura and you get a free token for your RPC API, or when you pay for something, usually you're not going to get, you can do 1 request per second. Usually it's more like you can do X request per hour or per day or per month. Sometimes actually a bit of both. So now we have an API which is pretty much the same. So it's like you can buy a membership and this gives you, let's say, 100 messages per 10 minutes. All right, so just to go back to what we're seeing here. There you go. So the epoch are sliding, right? So 10 minutes. So for everyone, an epoch starts and then lasts for 10 minutes. And during this epoch, you can attach new proof to each message. Each proof will be different. And every node in the network knows that this key has used 1, 10, up to 100 proof. Because we use zero-knowledge technology, we don't know what messages, all right, are linked to the same proof, to the same key. Okay, so you still have this anonymity. So someone outside the traffic can't see that these 10 messages are coming from the same sender from using the proof, but we do have the rate limit in place. And then after 10 minutes, when a new epoch starts, then we can forget about all these proof messages and we can start to count again. So with RNV2, for a node to verify that someone is not exceeding the rate limit, they need to remember the nullifier. So nullifier is a piece of data in the proof. So for every message that goes through the network, they can check the proof and then store the nullifier for this epoch until the epoch finishes. So the nullifier is 128 bytes. So when looking at why 10 minutes, it's a question like why not doing 1,000 messages per day, for example, which would be much more flexible for a user, right? A user, most likely, if let's say in the context of a chat app, you use your chat app, 6, 12 hours a day, and overnight you're not using it. So every 10 minutes at night that you're not using it, you kind of lose the opportunity to use the chat app, right? So ideally, 24 hours will be better, but we do have some limitation, and that is around storing the nullifier for the epoch. So if we look at, let's say, 600 messages for an epoch, which is maximum rate limit for one publisher, this would be around 75 kilobytes per user, which means that for 10,000 users, it would be 700 megabytes. So 10,000 users, why 10,000? It's because we think this is kind of a good maximum size for a gossip sub network. So for one given network, you have to keep in memory up to 700 megabytes of data for this epoch. And if you can't keep that in memory, it means that you can't verify proof anymore. And if you can't verify proof, it means that you might forward spam, and you might then get disconnected by other nodes that did. So the memory usage is very important. And in terms of, just so we are clear here, this is about node on the relay network. In our case, it's both nodes as VPS in the cloud, as well as on the desktop. On mobile, we don't forward traffic, so we don't need this on mobile. But so if you Raspberry Pi, if you start to use several gigabytes of data, we try to be a very lightweight client. So that's why we went for 10 minutes for now. We could always increase the epoch size or reduce it depending on when we use it with users and getting feedback. Another thing with the 10 minutes, which is good, is that if you go for a rate limit per day, so per 24 hours, one risk you may have is someone publishing all the messages he can at once. And in this case, you can have a peak of traffic. And this peak of traffic may, again, lead to DOS protection. We think with these numbers, we think it's fine. However, if we were one day able to, let's say, compress the unifier or something like that and move to 24 hours, then most likely we may have to have like a dual rate limit where we may say we can do 1,000 messages per day and 100 messages per 10 minutes or something like that. So yeah, so basically like a lot of parameters to think about when deciding for rate limit. All right. So just trying to do some prediction, try to do some statistics. So in average, just doing some distribution, we could look at the traffic of 266 messages per second, and average message size of 4 kilobytes. So the maximum message size is 150 kilobytes, but we don't expect every single user to send maximum message size all the time. And actually, 4 kilobytes, looking at the status chat application that uses Waku, is actually a good average that we can see in our infrastructure. So GossipSub, we use GossipSub like Ethereum. 6, the out degree is basically the number of peers that you are connected to and forwarding message to, and also the number of these peers also forwarding message to you. So which means that with these numbers, we can we'll get around like a 6 megabit per second network, right? And we split our network, as Alvaro mentioned, we split our network per shard in 8 shards. So which means that now we are assuming uniform distribution between the shard. So assuming that network is uniformly distributed between the shard, we end up with a traffic of 0.75 megabit per second per shard. So much lower. That's what we discussed before with the one message per second. And that again, here it's these are statistics, right? So that's what we think would happen. But then, of course, it depends on the applications that use the network. All right. Any questions so far on RNV1 versus RNV2? So V1, we had to do 1 message per epoch, and now we can do n message per epoch, and it's much more flexible. So yeah, so that's one of the. So we basically three main improvements. One was the message size, so the number of messages, and the second one is the market tree on chain, and the last one is we have defined some economics around the memberships. So just going back 1 second. So what's the point, right? So the point is when you want to send messages to the network, you have some rate limit. So you don't overwhelm the network, you don't overwhelm participants in the network, and practically dose them out of the network. So if we have a system where anyone can just grab any membership, then you end up having the same problem, right? Someone can come in and take all the memberships or take a high number of membership and attack the network. So you have to have some friction to ensure that you have to rate limit that as well, right? In some way or another, have some friction to ensure that no one just come in and grab all the memberships. In Web 2, right, in the normal, classical, I would say, world, you usually have some rate limit by IP. And that's why quite often, when you try to use VPN or Tor, you may have to have CAPTCHA. CAPTCHA is another rate limit, right? So rate limit by IP, rate limit by CAPTCHA, and sometimes you do have to provide some personal information, your phone number, your email address, social security number, and all of that. So in the case of Waku, we are trying to build privacy, anonymous, censorship-resistant infrastructure. And of course, so we want it to be decentralized for that. So don't really want to collect people's phone numbers to allow them to have a membership. And that's why we use a smart contract. So now in terms of smart contract, I think there is many ways to do it, right? So we are currently looking at pure financial solution. But that's just like one example that gets us going without making too many assumptions. But you could definitely have things such as, actually I will mention that at the end. All right, so economics. So we now assume we're going to make people pay to buy a membership. So we went for 6 months membership. When you have to buy a membership, and it's valid for 6 months. And at the end of 6 months, you have a 1 month grace period. At the moment, we went for a linear price, all right? So we say, okay, let's pay 5 cents per message per epoch for your rate limit. So if you go and buy the lowest membership, which is 20 messages per 10 minutes, you pay $1. And if you went for the highest rate limit, you pay $30. In terms of gas cost, so I think our demonstration was using a contract that didn't have yet the economics in there. So now actually we just look at the test, and it's around 232,000 gas to insert a membership on the smart contract with the economics in there, which is around $10 a minute, which is, for 6 months. It's not the end of the world. Looking at L2s, it will be more like around 70 cents, of course, depending on the L2 and the current gas price. So at the end of the 6 months, the membership can be extended during the grace period. At this point in time, we are not trying to lock in money, like to make money from that. So it's a deposit, all right? So at the end, if you want to extend your membership, you just call the contract. You're going to pay gas to call the contract, but you don't need to put more deposit in. And if you want, you can also withdraw your deposit during the grace period, after the grace period. If people just insert a membership and they just leave it there, as I mentioned, there is a global rate limit on the smart contract, right? So the smart contract will not accept membership above a given limit, which was 160,000 messages per epoch. So if there is no more space in the market tree, then a caller can override expired membership in there, so that if people don't renew, we don't have to extend the membership on the contract. We can just, the caller can just override. A quick mention, so we do have, cap on the rate limit on the contract. So what happens if we have a network with that many users, right? As we mentioned, we do split the traffic in 8 shards. So the idea is that if we end up at a point where the smart contract is full, and we do see this traffic on the network, then it's always possible to potentially deploy a new smart contract, or maybe modify the current one, like change some parameters, and add new shards. And to add new shards is just a consensus between operators. So just saying, okay, operators, let's have a new shard on the network, maybe a new smart contract with a higher rate limit, so that we can scale the network and get more users in. Cool. So, all right, so that's the current status. We are still refining the smart contract, more or less ready. We try to deploy it on mainnet very soon, probably in an audit first. In terms of the future, so we went for 6 months membership. Probably we can do 1 year membership, but it's still quite early on, and we didn't want to lock in parameters and having to try to get people to migrate if we change things drastically. But most likely, a yearly membership will make more sense. At the moment, we have linear pricing, right? So, 5 cents per message per epoch. We could have non-linear pricing. So actually, we already prepared the smart contract for that. So that, for example, you could have a bulk discount if you go on the higher end, or on the contrary, try to make it more expensive to have a higher rate limit. Now we need to basically get it used so we can get some feedback. One of the changes, so the reason Waku was built was for the Status chat app, which is a chat application, both mobile and desktop. New version 2.31 just released, so go give it a go. So right now, the next step to have RLN used is for us to get it in the Status chat app. And the main challenge here is to look at the current chat protocol and understand what would be the impact to reduce to rate limit, to add this hard rate limit. All right. So another point is that, especially when you think about chat application, I know WhatsApp used to cost $1 a year, long time ago. I don't know if you remember that. It sounds, okay. Anyone project developer that wants to build on Waku and want to take advantage of this decentralized peer-to-peer network might say, I don't want my user to pay and to do on-chain transaction before they can use the application, which is a fair comment. So we have considered having message going for free on the network, but it will just make the network more unreliable. So instead, question is like, how can we offer free membership to users, which is counterproductive, right? Because again, it is the right limit to avoid people flooding the network. But there are some options. So one interesting option is stealth commitment. So stealth commitment allows you to have someone else insert a membership for you and revealing very little information about your own membership. We could use Paymaster, right? So if you look at at layer 2, you could deploy a Paymaster to say, all right, if someone tries to insert a membership and they have some on-chain history, for example, they already bought an ENS name, or they do have some ETH, or they have some specific tokens that you are interested in or related to your project, you could say, okay, this user has on-chain activity, they're already part of my ecosystem. When they go and try to buy membership, I will pay the gas, pay the fee for them. And finally, a referral system. So one I think very interesting one is at the end of the day, you just have to enter a specific number in smart contract, like the public key, and there is a way to do that as well without revealing too much about it. So you could just have a referral system where someone that is already has an Ethereum wallet, already has gas, is to pay gas, could insert the membership for someone else. Again, once the membership is inserted, you don't have to do anything on-chain anymore. All you have to do is do some calls on the contract to get Merkle proof, to get your index, and then you can generate proof and publish on the Waku network. All right, so that's the most part for the presentation part. Any questions on cost and membership? Don't be shy. All crystal clear? Ah, yes, Q&A. Are you doing it? Or? All right. Oh, awesome. Questions. Awesome. No question. If your node closes often, do you need to resync every time before sending? No. So you do not need to resync messages per se before sending, at least at the routing layer. Okay, so if you miss messages from the network, then you miss messages. And then it just depends on what is your application. And in this case, and then it's up to your application. If your application is a chat application, then maybe we want to retrieve messages because there are chat messages you are interested in. In terms of the smart contract, when you restart, you do need to check the latest Merkle proof from the smart contract, because you do need to have the latest Merkle proof to generate the proof, right? If you use an old Merkle proof, then your message may be rejected. So you do have to recall the smart contract to double check to get the latest Merkle proof, and you do have to watch the smart contract as well, right? Because every time someone inserts a new membership, the Merkle proof change. The Merkle root change, and hence you have to have a new Merkle proof. You have to use a new Merkle proof to generate your proof locally. So you don't need to do a big resync per se. First, top question done. Is a deposit necessary since the transaction is needed anyway? Wouldn't just the gas paid be enough friction? Yes, no, that's a good point. It's a good point, especially on mainnet, where it does cost some money to interact with the smart contract. However, here's a question about security assumption, right? So how much should people pay to get a membership and send on the network? That's something that we have some theory around it, but we need to see practically what happens. And most likely you prefer to use the L2 so things can go faster. Like most applications more and more are using L2s, and on L2 it's very, very cheap, and hence the question becomes moot. So because our aim is to deploy L2s, and we develop this strategy. If indeed someone wants to use RLN on the L1, they might decide that the gas cost is enough, and that's fair enough. So I think I play this one. Is there a way to pay the membership for another user/account as a way to onboard Web2 users, for example? Yes, absolutely. So buying a membership, you just interacting with a smart contract, right? And you are sending and you're just sending a commitment, right? So you're just sending a number to the smart contract with the payment to have the rate limit. So you can get this number directly from your friend, and then do the smart contract call for them. All right. As long as they know to check the smart contract, they don't have to pay gas. And with test commitment, you can also have a bit more privacy around this action. So yes, absolutely, you can onboard other users and pay their gas fees and their membership fee. Are you considering limiting by n megabytes per epoch rather than messages count per epoch? So yes, we actually thought about that. We should look into that. If I remember correctly, and I'm looking at my researcher, yes or no, is that it just makes it more complex. Much more complex, right? It makes it much more complex. So that's why instead we went for message count. And I think RLN v3, right, would help for that as well. Or am I confusing? Maybe, okay. So yeah, it's much more complex. So instead we have an agreement between node operator of the message size, so that they can decide to drop messages which are too big from the network, and you have the message count on the smart contract. Is there? Oh, can you scroll down, please? I think I replied all these questions. I think there was. Yeah, there is more. Yeah, scroll down a bit more. Scroll down. Yeah, okay. Are there any more use cases that can be applied with RLN? Yeah, absolutely, absolutely. So again, RLN comes from the privacy and scaling exploration group from EF. So at the end of the day, with RLN is you rate limit the number of valid proof you can generate for a given number. In our case, the number is an epoch. And we use that so as a timestamp, right? But let's say you could do voting, right? You could have a proposal. The number is a proposal number, and you can say, okay, we can do one vote per membership, and you could vote in an anonymous manner. I haven't looked lately about RLN applications, but yeah, it can definitely be used for other applications. Have we considered restaking to secure this instead of introducing a new token economy? Do you know? Yeah.
So, yeah, that's an interesting question. We haven't. That's the short answer. But could be interesting, actually.
There you go. Would upgrading from RMv2 to v3 in the future be a breaking change that would make nodes on the previous versions not work with the new ones? Okay, so first, not sure we would ever upgrade to v3, but in any case, it is a consensus, right? So in short, when you run a gossip subnode, all right, you are going to have rules to validate messages, and everyone needs to have the same rule, because otherwise you get spam and you're going to say, okay, this guy is sending spam, so I'm going to disconnect from him. So whenever you want to upgrade the network and change the smart contract, there are several ways to do it. You can just start to point to the new contract, and you're going to disconnect people that are still pointing to the old contract and connect to people that are pointing to the new contract. You could have, and I think that's basically like the main strategy here. Because as soon as you could have strategy as well where you say, okay, from this point, from this timestamp or from this block, we are going to start considering messages valid from a new contract or from a different contract. So it is somewhat of a breaking change, but Gossip Sub has self-healing properties, right? So it wouldn't last for days and you have a hard fork or anything like that. It would be more about the question of having the Gossip Sub peer scoring mechanism to kick off and heal the network. Can you scroll down, please? Yeah. Oh, all right. Do we pay in ETH or some other token? How is this 30 USD paid? Yeah, it was on the slide, but I didn't mention it. So at the moment, ERC20 token, all right? This is a parameter of the smart contract. So when you deploy the smart contract, you can decide which ERC20 token you want to use. In our case, we thought it was important to use a stablecoin. So we went for DAI, because we are decentralization maxi, so we went for a decentralized coin. So we suggest to use DIVE, but it is a parameter of smart contract, and you can just choose whatever you want when you deploy it. Potential whale can fill the tree with membership very quickly. Is there a way to mitigate it? I'm remembering the discussion. We had quite a few discussions around that. So yeah, at the end of the day, a whale could come in and fill the tree. And this is one of the reasons I think expiry is very important, right? Because if they do, then we have to cost enough so that they do it again and again and again. So in terms of security, at the end of the day, any security problem, the question is, what is the cost opportunity versus what could you gain, right? Quite early stage here, so someone would do that, it would be just quite annoying, but we just deploy a new smart contract and just get the node operator to point to the new smart contract. We did think as well about limit, like, saying, okay, one membership per Ethereum address, for example, per wallet, right? But this could be, you could still go around by just, dispatching your money on several wallet. So I think at the end of the day, expiry does play in there. I wonder if Sergey has more to say about that. About the whale problem. No, okay. It is a fair comment. It is a fair comment. Okay. I think no more question? More question from here? Awesome. Anyone has tried the Nwaku Compose? Oh, right now. Do you want some help? Is it working? Or you tried it in the past? Do you need some Sepolia is? Yeah, we can help. So, okay, cool. I think we can stop the presentation for now, and then we can help anyone that wants some help or some questions. Cool. Thanks.
Is this working? It is. Great. This is for experts. Hi, everyone. Thanks for being here. It was about a year ago that I was at the Solidity Summit in Istanbul and introducing the work that was just getting started to build a debugging data format. And so I figured it would be appropriate to come back a year later and report my progress and hopefully, you know, disseminate information about what I've been working on in hopes of getting people to adopt the standard. I'm going to try and get to the interesting technical stuff, but first I'll do some high-level overview, and that's we'll probably run out of time, but I'll make sure to leave room for questions. Yeah, just to get into kind of the high level, go over, you know, what is this project, what is it for, why is it important. Making debuggers is hard and brittle, and it takes a lot of guesswork. Like, I don't know if you've ever looked at EVM bytecode before, but it is entirely opaque, and so. I mean, of course, this isn't a problem just with Ethereum and smart contract computing environments, but also for traditional computing environments. But on traditional computing, what they do is they have the compilers provide more information, and that has worked very well since the 80s. We have debuggers. Debuggers, even in the last 10 years, are really quite impressive these days. But for smart contracts, the question is a little bit less, or it's a little more non-trivial. Like, what information do you actually need the compiler to output, and how should that information be structured for this, like, our unique computing paradigm? So let me introduce the project, maybe not get ahead of myself. So ethdebug, the ethdebug format is an effort to build a debugging data format. A debugging data format is the term that they use for the information that is output by a compiler that enables debuggers to exist, at least to exist without spending way too much money building them. So that's what the ethdebug format seeks to achieve. We are funded by the EF right now. We are proudly part of the Argo Collective spin-out. You should all go to stage 2 at 5 p.m. to hear more about that. That's the last thing I'm going to shill apart from my own work. I get this a lot I put on there. We're not building, ethdebug is not building a debugger. We're building standards. Yeah, we might build a debugger in the future, but debuggers already exist. I just want to make it a little bit easier and cheaper to build a debugger. So, who am I? Well, I'm Nick. Nice to meet you all. Thank you for coming. I'm the lead for the ethdebug project. I am a member of the Argo Collective. I have built a Solidity debugger, and then I oversaw it for 5 years, and it is a nightmare. I have worked on projects that are now ancient history, and I just kind of work in the dev tooling space. You know, stuff interests me quite a bit. So just to try and churn through these non-technical things. Project goals. Yeah, we want to make a universal format. I don't want a Solidity debugger only. I want a Solidity debugger that is also a Viper debugger, that is also a Phi debugger, a Hop debugger. And I don't just want to target the use case of I am a software engineer that needs to figure out why my code went wrong. I think it is also important that we target use cases such as why did someone else's code go wrong and lose $1 billion? So things like auditing tools, analysis tools are very important, and I would lump them into that same kind of category. On that topic, it's very important for Ethereum and smart contract platforms that we target not just like debugging in development, but as I'm sure you all can understand, it is extremely important to be able to understand why $1 billion disappears because of software. So that's, you know, a little bit more challenging than your GNU debugger and your local build of your C project or what have you. And because this stuff is hard, it's clear to me that we have to make it a goal to really optimize for adoption, right? I have the Solidity team in the room here supporting me in this talk, and I feel very bad for the work that they will have to do to support a project like the ethdebug format. And on the debugger side, it is only marginally easier, but again, it is orders of magnitude cheaper and simpler to take an approach like the one we want than debugging today. Ultimately, right, the idea is we want to lower the cost of understanding the blockchain, right? We want it to look at the EVM and understand what's going on, or have like a dozen tools to choose from that are all reliable and are well architected, right? Like this is a future that would be nice. It's a future that, or it's like a present, unlike your x86 architectures with your traditional languages. And so I hope that we can move in that direction for smart contracts. So this is a series of steps that I have followed many times, and I would imagine that a significant number of the people in this room have also done this, where they need to understand how Solidity works. Some like strange feature, like how do mappings get stored in Solidity, or strings, or what have you. And you know, many times the documentation is thorough, and many times it is like even the Solidity engineers don't exactly know how modifiers work all the time, stuff like that. It's quite bizarre. So what do you do if you're trying to do some blockchain like smart contract analysis? Well, you sit down with Sol C and a bunch of input examples, and you compare it to the output examples, and you scratch your head and you think, is this how Solidity does it? I think this is how Solidity does it. And then you go and you write your code and you implement it, and you start like slurping blockchain transactions and figuring out what's going on. And then you realize that, oh, actually in 0.8.6 there was a change, but turns out I was just wrong actually also. And then you go back and you spend another few weeks trying to make sense of how Solidity behaves and how your implementation should behave. And you know, this is kind of annoying because people do these steps for the exact same problem. Like finding strings in storage, like many people have done that same thing. And why? Why do you have to repeat the work? So also, that's just Solidity. People don't even try to the same degree with Viper. Like yeah, there are some Viper tools, but like people spend a lot of time, like I would argue wasting time making sense of Solidity. And there just isn't that for Viper. But you know, Viper also is responsible for billions of dollars of assets. So I think this is a pretty significant concern that we cannot ignore. Here's an example. This one's at least documented. Like the Solidity docs are quite clear on how this works, but it's still very bizarre. Yeah, Solidity has two different ways of storing strings. If the string fits in 31 bytes or less, it goes into one word. If it's longer than 31 bytes, it goes into at least one word, and then, you know, or at least two words. And those words are not consecutive, right? So like in the first example, it's, what did I have, slot 0, and then the second example is slot 1 followed by a catch-jack hash. And then you start counting, you know, incrementing using the catch-jack hash. This is very weird. How does it work? Well, that last byte at the end tells us two things. It tells us the length of the string and whether or not that length is longer than 31 bytes. And, well, the second point is whether or not it's odd or even. I mean, I don't necessarily need to go into the examples. You can look this up in the docs, or you can see the gist. But it's weird. This is not the only weird thing that EVM languages do. So how do you accommodate that when, you know, the last 30, 40 years of debugger development has assumed that people are organizing data structures with like normal ways of organizing data structures? Well, we don't have that privilege, so here we are. Shall we get into it? Here's kind of the model that we've been working with, right? Is like there's that debug format, and there are compilers and debuggers, and there's some interaction between the three. And I won't assume that the people in this room all know how compilers work, so you can imagine, well, there's source code that goes into the compiler in a high-level language, and there is machine code that comes out of the compiler in a low-level language. And in between, there is a long pipeline of many different steps, some very complex, some straightforward. The compiler does things like when you make a function call and the compiler has to convert that function call into machine code, it generates at least two jumps, you know, one jump to enter the function, one jump to leave. Or if you are storing a struct or an array, the compiler has to take your single assignment statement and convert it into a series of like individual word assignments. And in order to, you know, what you're left with if you're looking at the EVM, like the raw running EVM, is you don't necessarily see any way to translate back, right? Who knows? You just moved a word. I don't know if it's part of a struct assignment or what. But if the compiler were able to keep track of every single transformation as it performs it, right? Oh, I have to convert a function call into a series of jumps. Well, if you annotate those jumps to say this was the start of the function call, this is the return of the function, well, and manage, if the compiler can manage to preserve that information all the way to the end of the compilation pipeline and produce like a nice JSON object, well then the debugger can read that information, observe the running state of the EVM, and basically see, oh, we're executing this instruction. What has the compiler told me about this instruction? Oh, it is a jump that is part of a function call. So with that, debuggers can actually make sense, like a coherent mental model of like this like fictional high-level world that is lost once the compiler is done. And the idea is hopefully this should be sufficient for debugging missing billions of dollars in optimized code. We do have challenges. The first significant challenge that has been on our mind is the fact that when you debug something, you are debugging runtime. And unfortunately, the compiler is not capable of predicting the future and knowing what runtime will be. So like, if you want to allocate an array in memory, you have to put it in memory. Where does it go? The compiler cannot guess what address in memory that array will have at compile time, because maybe you are allocating 5 arrays or n arrays. So we are limited in that the compiler can only know so much, and there are these gaps that like we have to take these like runtime observations, like, okay, how do I take the running EVM, pair it with this compile time information, and produce a cogent model of the high-level world? That one's not too bad, maybe. Of course, optimizers make it even more complicated, right? When you have techniques like bytecode deduplication, right? I mean, optimizers are very important for smart contracts because you have to pay for every operation, and it is significantly more expensive than most computers. So, you know, you might look, if you're writing a compiler, you might be tempted to say, well, oh, this series of source instructions, like this source code, is very similar in its output to this other part of the source code. So maybe I can reuse the bytecode for those two same pieces, like the two different source ranges that, like, you know, maybe they're in 2 different files, maybe they're in 2 different functions, whatever, but they would produce the same exact bytecode, and the compiler would jump into that bytecode in either situation. So how do you annotate this like low-level information? Suddenly you're going from, well, this instruction didn't necessarily just come from here, it came from either here or here. So we are effectively stuck with this like disambiguation situation where a debugger will not be able to necessarily understand with full precision like what the debug information is saying, but the goal is to ensure at least accuracy with that. Like maybe we can't be fully precise, but we can at least target not being wrong. And so it's like, hopefully, if you have a block of bytecode that corresponds to 2 different originating sources, the debugger will have other information in its internal state to be able to say, oh, okay, well, I know that we were in this state, so we must be following this code path. And then another time when we are in this state, we must be following the other code path. What do we have so far? Well, we have a bunch of JSON schemas. I would estimate probably about 60% of our like working data model is implemented in schemas, and the 40% is a lot left, but at least we, you know, have been working pretty hard on it. Like we have examples for every schema. Those examples are all tested. You know, I don't want to have to fix things that I didn't realize were broken in the future, right? And on the adoption concern, right, I do want people to use this format. I'm glad you're all in this room listening to me, because maybe I will convince you to go and implement this. If you do, there are explainer documentation sets for all of the schemas. And we have right now at least one reference implementation for what is the most tricky schema so far. But the idea is that I think it's very important that we build reference implementations for all of the schemas, hopefully on both the debugger side and the compiler side. So if maybe you're inventing a new language or something, and you go to the ethdebug website and see, okay, this is how an example compiler might implement this stuff. I will copy that. Or I'm building a debugger. I go on the website. I see, oh, this is how a debugger might implement this technique. And I really just want to make this as easy as possible. these are the schemas that are furthest along. I'm running out of time. All right, well, I'll have to run through it. So we have a program schema, which represents a single piece of bytecode, and it's structured as a list of instructions with annotations for each instruction. We have a type schema for describing variable types. Hopefully that's self-explanatory. And then the most complex / complete schema so far is the pointer schema, which is to describe data allocation strategies from a high-level language. And I'll go into a bit more detail on those. So the program schema here, if you want the direct link to the explainer documentation for that, this schema is quite incomplete, but the foundation is there already. The key concepts of the program schema are it's one program is one byte code. Programs have a list of instructions or instruction annotations. Those annotations allow the debugger, like describe a high-level context and allow the debugger to basically have a lookup table. When it reaches an instruction in the bytecode, it can go and consult the debug data and see what is happening with that, ultimately informing the high-level state. This is an example, if you want to see. So it's like the offset's the program counter. I think with the OF, they're not really calling it program counter, or it means something different. So I just called it offset. You can see the operation that instruction is doing. You might recognize this as the start of every single Solidity contract. In this example's case, I also added a source range, so you can kind of see, oh, this is the corresponding line of code. And it looks like in this example, we already have a storage variable available to us. So that's like at the first instruction, we can read X, which is of type string, and it's in storage slot 0. I'll get into the type and pointer schemas in 2 slides probably. First, I have to give you this warning. Yeah, we haven't tested a lot of our assumptions here, just full disclosure, but we think it's viable. But stay tuned. You might see me very happy or sad next Devcon. All right, the type schema is pretty straightforward. You have to just describe types. So we got known and unknown types. Like there's like uint, strings, like all the normal ones are supported by the format, but we also allow compilers to define custom types if they have, some advanced type systems. From there, types are divided into either elementary or complex. We do need algebraic types, but they don't exist yet in this schema. Elementary types are just like a single thing, and complex types contain at least one other type. Types, to deduplicate representations, like there's a lot of data that we're talking about. We allow types to be referenced by ID. If you don't want to just copy long descriptions of arrays or structs over and over, you can just give them an ID. And of course, if it's a user-defined type, it can point back to the originating source. Here's a couple examples. It's pretty straightforward. On the left is an elementary type for a fixed point number, and then we have an array of uints as a complex type. There's more examples on the website if you want to find them. But this is really what I want to talk about is the pointer schema, because this is, I think quite interesting and suggests that this approach might be viable. So we need to represent where variables live. Oh, I should probably get this over with. Yeah, so you guys can probably just go. Unless you like this kind of insanity, then please stay. But yeah, so we kind of put lambda calculus in JSON schema. And that's because of the compile time constraint, which is, the compiler doesn't know where something's going to be before it exists, right? So basically, we get an expression syntax with this schema to describe, like, where is that string storage? How do I know, based on the state of the machine, whether or not the string is short or long? Let me show you an example. See? Oh, yeah, here's the example, actually. Yeah, don't look at the slide, just grab the QR code. I did document this. There are comments there. But you can kind of see at the very top, this string storage, this pointer starts with a storage slot 0. And then we have a group of other data regions and variables. I mean, I'm really running out of time. Maybe I'm supposed to ask for questions now. But you can see, is there a laser pointer on this? Well, I can just point. I really can't. So you have groups of, basically the way the pointer schema works is you have regions and collections. Regions are a single like continuous range of bytes, and then collections are this like abstract thing. You can have groups of regions, you can name the regions, so you can have conditionals, so you can do things like check the remainder. Is it odd? Is it even? If it's even, we know it's a short string, so do this. Otherwise, we know it's a long string, so do that. Remember the example from before? Great. All right. I swear it's less bad than you think. I mean, the idea is that these are actually static representations, so the compiler will only need to output this once, fortunately. You know, and then instead of 0, it would just be a template variable, and then the compiler can say, use this pointer with this variable in place of string storage contract variable slot. And this way, you know, any supporting compiler can just output, like have a library of these pointer templates and just output them whenever they're necessary. And if they're not necessary, it can omit them. Yeah, I'm apprehensive, but we tested it end to end. I put a string into a Solidity contract in an automated test, and I step through the EVM and I observe after every string assignment that the value changes and matches the expectations. So if you want to see how it works, you can look at the implementation guide. Hopefully it's coherent. All right. Anyway, there's a lot of work to be done. Feeling very good about it. You know, I think this is a solvable problem. If you want to learn more, please join our Matrix chat. We meet every other week. You're welcome to join the calls. You can also just watch the repo. Ooh, we got questions. Yeah, thank you. Exclude the optimizer. Yeah, so that's the approach we're taking. Will these get recorded? I should probably repeat them. The question is, can we exclude the optimizer and just focus the debugger at compiler level? Optimizer should not be altering code functionality. Unfortunately, I think it does alter the code functionality, but the approach that we've been taking so far is to start with just unoptimized code while thinking about, you know, what do we do about the optimizer and making sure that we're not painting ourselves into a corner when we do want to support optimized code. When is at debug format done? After Devcon. Others? This is so impersonal. Biggest blocker? I mean, the tricky thing with work like this is that it's periods of challenging, like thinking, figuring out, like, how can I make this meet the requirements, followed by months of tediously documenting. And so it's like there could be blockers in, you know, either of those, and in both situations the blockers are quite different. Can the debugger identify the function arguments if the format is followed? Yes, that is the idea, right? So if I didn't have only a 25-minute talk, I would have bombarded you all with way more examples. They are on the website. You can kind of see. If you look at the program schema, I actually handcrafted a pretend high-level language source and the corresponding opcode output. So you can kind of take a look at what that looks like. How do I scroll down? Looks like there's more. Any plans on decompiling deployed bytecode with no original source? I mean, this is a cool thing. It's not really my area. I know there are decompilers that exist. I just haven't, you know, thought about that too much. Oh, any more? Well, thank you for your time, everybody.
welcome. Thank you for coming by. This is Lucas, and I'm Connor, and we're here from the base team, the Smart Wallet specifically, and we're here to talk about this new feature we're launching soon called Spend Permissions. So Spend Permissions, that title got messed up, sorry. Spend Permissions allow you to create one-click or no-click experiences that can spend users' tokens. This is important because we all want better UX within Web3. It's kind of annoying to have pop-ups all the time when you're doing a transaction. And so with Spend Permissions, you're able to give permission to an app to spend your tokens so that the app can do fancy transactions to pull your assets and then do fun things with them. And this workshop is going to show you one of those things is a social app. A few minutes, talk about our roadmap when we're launching this and when you can get started building. And then we're going to talk about some fundamentals. This is where the workshop actually begins. We'll be doing some live coding, and you can fork our starter repo. And then we're also going to be finishing with an NFT micropayment use case at the very end. So for those of you not familiar with Smart Wallet, it is a smart contract account that has self-custodial passkeys. This means that users can easily onboard if they have a device that supports passkeys, which is most people in this room. You can scan with Face ID if you have iOS, or thumbprints if you have your computer or your phone with a thumbprint scanner. With Smart Wallet, you can also sponsor gas for transactions so users can convert easier and not have to fill up their wallet to get started. And you can also batch transactions to make it easier for people to do things with less steps. But one of the problems we've encountered with Smart Wallet and all wallets in general is that there's still too much friction to transact. People really are addicted to one-click experiences like we have in Web2. So there are two ways that we've actually explored doing these one-click experiences, and session keys is where we actually started. And it's this idea that you can give permissions to apps to transact as you. And so literally the popular way people implement this is they can take control over your account to call other contracts. And it's incredibly flexible, but after exploring this deeper, we realized that this actually has some security discomfort for us, and we don't want to let apps call random contracts on our behalf, even if we inform the user what's being called and what functions. We just don't believe that users are informed enough to give approval to those kinds of permissions. And so that's what brought us to Spend Permissions. It's a way of tightening the scope of what we allow apps to do on behalf of our accounts, and it's focused only on spending assets. We think that spending assets is actually the majority of the reasons apps need to interact with accounts. And after an app has assets from the user, it can then do things like mint NFTs, swap tokens, staking on DeFi, whatever you need. And in this sense, we actually feel way more confident with the security posture of spend-only permissions, and you can still solve the majority of the things we care about. So what are the use cases we think people want to build with? The first, which we'll demo today, is microtransactions. These are high-frequency interactions that you'll want users on your app. Because they're high-frequency, it's naturally very annoying if you have a pop-up every single time. And so use cases like this in social would be a Zora app, where it's basically Instagram, but instead of liking, you're collecting NFTs, you may be liking all the time. Other microtransaction examples would be gaming, very high frequency. People want to go through many operations for a game potentially and do it quickly. And so before, you would have a pop-up every time, but now you can just give permission once to spend some ETH or an ERC20, and then whenever you click a button or do something in the background, it's just going and transacting without you noticing. The second use case we're really excited about is subscriptions. This is an example of a pattern where users don't have to be on the app anymore. And this is where permissions really shine, and you can do things uniquely that we couldn't do before with wallets. And so in a subscription case, you will give your app permission to spend your tokens on some recurring basis. And then even when you're outside the app, it'll just pull money from your wallet, no pressure needed. And so in this case, subscriptions are not the only background process you need to do. Other background operations could be automated trading, copy trading. Things that are more DeFi native also shine very nicely with background transactions. But these are the two that we think are most relevant immediately. So how does this actually work? So this is a sample diagram of what on-chain looks like. And typically a smart wallet, we think of having one or a few passkey owners. And so you can see the smart wallet contract in the bottom left. It has an owner relationship to a passkey. And we typically reference that passkey by its public key, so 64 bytes. Smart Wallet also supports owners that can be Ethereum addresses, which includes smart contracts. And so for the spend permission system, we're actually adding a new contract as an owner to smart wallets called the permission manager. And through this ownership system, we're able to delegate other permissions to spenders. And so you can see the spender relationship between our permission manager and a spender entity, which is itself another Ethereum address. And so once you have this ownership relationship set up, the flow of a transaction looks a bit different than normal. So originally, transactions for session keys originate from the smart wallet account, but this time a spender is calling through the permission manager to spend some tokens. And then the permission manager, being an owner, is able to call execute on the smart wallet to get it to call anything at once. In this case, we want to call the smart wallet to transfer some value, and in this case, back to the spender. And so, yeah. And so how do you actually use this off-chain? The first thing we need to do is approve a permission from the user. We do this with ETH sign type data. It's using EIP 712 signatures. We chose this path because it's the easiest way to ask the user for a signature of structured data. Before we were working on a standard called ERC 7715. We felt that 712 was actually an easier place to start, but we're still open to working with 7715 in the future. But the user sees a very simple approval here, where the app is just asking them to allow it to spend some currency on a recurring basis. In this case, 10 USDC every month could be a very simple transaction subscription experience. And we also have a start and end time. So in most cases, you'll want the start time to be right now and the expiry to be sometime in the future. The apps we've been talking to typically want the expiry to actually be infinite, which is something we think is interesting, where users would have to revoke if they ever want to remove the permission. But that's up to every app to decide for themselves. After the user's approved a permission and then therefore signed it with their passkey, the signature is given back to the app. And now the app can use that signature to apply it as an approval on-chain. And that's that first optional call in the top. After a spender has approved the permission with the signature from the user, it's able to spend. And so then that's number 2 on this diagram, where the spender is calling into the permission manager to use the permission. The permission manager will then validate it, call execute on the smart wallet, and depending on if you're using native token or ERC20 token, the smart wallet will either call directly back to the spender to transfer ETH, or call the ERC20 contract with the transfer function to send the tokens. The third piece here is revoking. It's very important that users are always able to revoke permissions after they've approved them. This is fortunately a way we can actually differentiate from TradFi in the existing world, because it's very frustrating that you can subscribe to an app but not easily unsubscribe. A lot of apps make it very difficult, but we believe that in the new world, users should always have control over their assets and have control over their permissions. So permission management is always easily accessible within their smart wallet settings. And we also went through the effort of making revoking an entire app's permissions, in case you have multiple, easier with a batch revoke as well. So when can people start building with this? Well, as of today, we have, well, as of last week, we have Base Apolia supporting ETH and ERC20s. And in December, preferably at the start of the month, we're going to have this live on mainnet. On all mainnets that Smart Wallet supports. Right now, that includes Base, Arbitrum, OP, Zora, ETH mainnet, and a handful of other chains that are less used right now. But also in December, we're exploring ways of doing batch permission approval. So ways for a subscription, for example, that you can both pay now, but also give permission for the app to take your money later, which is a more typical experience that we have with permissions for subscriptions. And then in 2025, the roadmap is still pretty open. We're open to user feedback, developer feedback on how we can improve spend permissions and build other systems that complement it. Cool. Well, that's the brief overview of how the system works. Lucas is going to take over and give a sample workshop of our basic demo app. You can open this on your computer. It's github.com/lucasrosario/spend-permissions-demo. We'll leave this open for a moment for people to pull up. And also, before continuing, are there any questions about the overall idea or setup of spend permissions? Yeah.
What's the difference between batching transactions? What's the difference between batching transactions and having like a spend limit for, let's say, you have a $10 spend limit or $20 spend limit for the entire month? I'm trying to understand.
Oh, of that last point I had of batching permission approval?
Yeah, that one.
Yeah, so right now when you approve a spend permission, you're just signing a 712 object and nothing's actually happening on chain. And so an app could use that permission and immediately start applying it to pull money from you. So the batching permission approval idea is that you can use a transaction-based approval and then therefore batch other operations with it. So I could transfer ERC20s directly to the app and then also give it permission starting next month to withdraw my tokens. So it just makes the UX a little bit easier for the app.
Is it like, let's say, approve transaction as well as like swap transaction batched in a single transaction, and then you approve that?
Correct.
Is that? Oh, okay.
Yeah,
Got
yeah,
it.
yeah. And there are other ways we're also exploring batching where you could still do the 712 path and sign over multiple tokens at once. So a use case for this would be gaming. We've talked with Cattown, and they actually need ETH and Kibble, which is an ERC20, because they use the Kibble to fish, but they need the ETH for a Chainlink VRF fee. And so we'd still want to provide an easy way for users to sign once and approve multiple permissions at the same time. So that's the other pattern of batching. Yeah, another question.
Actually, like I already implemented the spend permissions in my app, like where I built an session keys based prediction markets, where users just swipe left and right for their action, and the app, it does the whole thing under the hood using the session keys and spend permissions. Like each transaction is 0.01 already capped. Like the user gives an allowance of 0.1 ETH every day, and we automatically abstract for 0.01 ETH. So the issue we occurred was like regarding the finality of the transaction. Like how does it occur? Like sometimes the transactions may fail, but we show the user like the transaction is succeeded because of the finality issues.
So if I understand the question, you have an app already on spend permissions.
Yes.
You have a daily refresh cycle, and then you're using the money to do some prediction market use case.
Yes, yes,
And some of the time, the transactions are failing.
yes.
Oh.
And
We should talk after then.
yeah, okay, thank you.
Yeah, I can help debug later.
Yeah.
Cool. Well, I want to hand it over to Lucas now. We'll take more questions throughout as well.
Cool. Yeah, so again, this code that I'm about to be showing is available at this repo. First, I'll just demo the app real quick. So yeah, this is a super simple app. This was spun up with on-chain kit, and I have a smart wallet connected here, and I can click the subscribe button. And what this does, this pulls up the 712 message to sign that Connor was talking about that describes the parameters of the spend permission. So you can see the limit per day is a lot. Starts on like forever ago. Not sure what that's about. And it's on base Apolia. So I can sign over this. And again, this is off-chain, so it doesn't cost any money or gas to approve a spend permission. So I can sign this. And then this signature is going to get shipped off to this app's backend, who can then use the signature along with the parameters of the spend permission to start pulling funds from my account. So that's what these are. These are all ops that are landing on chain. Yeah, so like every 5 seconds, the app will pull the backend to tell the app's like spending key to pull funds from the user's account. So that's like the short demo, and again, we're excited about this for like subscriptions, and this could show like this is kind of like a streaming payments kind of use case that I think could also be really cool. So we can go over the code actually real quick. So we can start with the front end piece here. There's nothing like super interesting here. Is this big enough? Maybe that's better. Yeah. So. As mentioned, this is just like a regular 712 message. The parameters for these you can find on smartwallet.dev, and we have a guide up on spend permissions now, so you can see exactly how these are parameterized. So basically, when the user clicks this button, we define the spend permission, the account. This is the user's account. The spender. This is my like if I'm an app, this is the account that can pull funds from a user's account. We have a spend permission for ETH for 10 a day, and this is these are the like recurring parameters, and then we have some extra fields here which you can find more about on smartwallet.dev. So we request a signature from the user, and then we make a request to the app's backend with that signature and the spend permission, and we can go see what that looks like. So. The account that we're using to actually do the withdrawing from the user's account is a smart wallet, actually. So we wrap a private key in a smart account, and the reason we do that is because it's easier to do than like batching. We can do atomic batching, and we can also use paymasters. So when I was setting this demo up, I spent like 30 minutes trying to get basically a ETH, and I actually just ended up wrapping the account in a smart account and using a paymaster, so that's much easier. So you can see here, we have like a bundler client, and we send these calls to the permission manager. That's the contract Connor was mentioning. That's an owner of the user's smart accounts. So we have an approve a signature. So this actually approves the spend permission on chain, which needs to be done so that when the withdrawal calls get to the account, then the spend permission manager has like a record that the user actually did approve the spend permission. And then we have the spend call, which is saying, hey, I have the spend permission. Given that I want to withdraw 100 Wei from this account. And like I mentioned, we have this set up with a smart account and a paymaster so that I don't have to think about gas. This is just going to be sponsored by my paymaster. And then we return the hash to the client so that we can see that list of withdrawals in this case. And then we also have this other simple route that does collection when the spend permission is already pre-approved, so you can save some gas here by if the spend permission has already been approved on chain, you only need to call spend to withdraw tokens from the user's account. And again, using paymaster, and then we return the hash to the client, and that's where we get this this list of hashes, and then we just render those hashes and link them out to a block explorer. So yeah, again, this is available on this URL. Feel free to just pull it down and play around with it. And again, we have a guide available on smartwallet.dev, and that goes into all the parameters of the spend permissions and goes into more detail. And you can find out more about like use cases we're thinking about there. Any questions about the demo?
Hi, thanks. I'm wondering, is this the spending permissions is creating a session key, right?
No, because session key, we're trying to be very clear that spend permissions don't allow you to arbitrarily execute for the user's account. In other words, like the spender account is not an owner of the user's smart account. It just has the right to withdraw some assets from the user's account.
Okay, so it's an extremely scoped key that can only spend assets of the user's account.
Yeah, that's right, and that goes to like we just felt much better with the security model there, but you can pretty much get to session key parity and just build like, you know, if you wanted to have some state tied to the account, you can imagine in this backend having, you know, some database set up that's like, you know, I have this spend permission for this account, and I can just have my state there, and I don't need to execute directly from the user's account. And I just need the assets, which I can do.
And so, last question: the signature here is happening on the client side.
Yes, the user signs over the 712 message, right. Which basically like gives the ability for the app's spender to like pull funds.
Okay, so at each spend is using the signature that the user gave in order to use the permission.
You actually don't need the signature after you approve it on chain. So you just put a record into the manager contract that says, here's a signature for this spend permission. This is valid. And then next time when I want to pull funds, I don't need a signature again. I say, here's the spend permission. And there's a record of that on chain that it was approved.
Okay, thanks.
Yeah. Any other questions?
So this will only work with the Coinbase Smart Wallet?
Currently, yeah. Well, there's nothing stopping other wallets from implementing this this feature, but you would need to have the owner added as on your account. What else? Is it like here too? Maybe not.
So the contract that we've written and audited only works for Coinbase Smart Wallet. However, we wrote it in a way that's easily forkable, where other people can just override a specific function of like what the execute looks like on their smart wallet. So for example, if you want to use, I guess, I think probably like a 0dev7579 account has a specific execute function, you can just fork the spend permission manager, re-implement the execute function, whatever that interface looks like, and then everything else can just work the same pretty much. So one thing,
No.
yeah, one thing we are exploring is if spend permissions needs something like an ERC to make it easier for apps to work with other wallets on this kind of feature. We've held off from doing that to make sure that the design is actually sane first. But that is something that we're open to talking about and working on.
Okay.
Yeah, thank you. Cool.
Do you want to do your thing now?
Yeah.
If there are no other questions, Connor's going to show another demo of how you can tie this into like a social kind of app.
Actually, I think I may just like wing it on this one.
Okay. So do you want to plug in?
Yeah. No, stay in for a sec. Actually, I want to take it, chicken.
Yeah.
Cool, we are back. All right, so we're gonna do this like half live. We want to show a more concrete example of what it looks like to actually do advanced operation server-side with spend permissions. And so what we're going to build is effectively something like this, where your smart wallet has some money, but we want to withdraw that money and spend to use some kind of operation. And so Lucas was showing how earlier we could use a Coinbase Smart Wallet server-side with a key that we can sign on demand. And with the Smart Wallet in the server, you gain two main things. You can use batch transactions, which we're going to show in this example, and you can also subsidize gas through paymasters to make it easy to not have to worry about topping up some random account you have with enough gas to submit transactions in an automated way. And so for this specific example, we're going to work with Zora's NFTs. That's just a good go-to protocol for anything NFT related and incentive alignment with your creators. And for us, the call flow is going to look something like this, where the entry point, because it's a 4337 account, is going to execute on our server account, which then has a server key we'll be signing with to verify. And then we're going to do two calls and batch them together. The first call is going to be spending on the smart wallet, which will prompt transferring some assets into it. And then the second call is going to be minting to the actual Zora NFT. We need to do the spend call before we do the mint call because we need ETH to perform the mint. The Zora's contracts will ensure that. It will only allow you to have the NFT if you're paying for it. And the mint to, emphasis on the two here, a lot of contracts out there allow you to define recipients for token-related operations. And so in our case, we're not going to be minting back to the server account here. We're going to be minting the token directly into the smart wallet itself. And by doing so, we create effectively what a session key experience is like with one-click mints, where the user only has to approve the permission to withdraw ETH. Then whenever they click the mint button, they're going to have the cloud account withdraw their ETH, mint something, and get it back in there atomically. This kind of model can also expand to other operations. So for example, DEX trading on swaps. The Uniswap router allows you to define a mint to like behavior as well, where you can define any number of recipients you want for your tokens. And so this is a case we're actually exploring with the team Dracula, where they support both swaps in their app and NFT mints. And we're working to move these operations to the server so that you can batch withdrawing money and buying something and giving it back to the user. And we think this model can actually be replicated across many other examples as well. And so what we want to do to start is I have an NFT collection on Zora. I've already done some sample mints in anticipation for the demo. But we have, this is just my PFP. And we have a contract address here. And so what we're doing, let's make that bigger. Cool. And so the first step here is rather simple. It's just the usual grant permissions experience. Again, you're just approving some ETH, and then you can do allow. And then from here, we have my PFP. This is the NFT I'm going to be minting. And then when we click mint, it should be making a query to the server to mint the token, which will then pull the assets if we have the route up here. 2 calls that we need. Or 3 calls rather. So again, we're approving the permission with the signature. We only need to do this once. After we have this approved on chain, we actually don't need to apply the signature anymore. But then we're pairing together both the spend of calling the spend permission manager to withdraw the amount we need for the mint. And then as soon as we have that mint value back in the spender client that we have, we can do a mint call. And then the mint call itself is going to make a call to the Zora minter contract with the mint cost and some data, which then just takes a bunch of stuff. But really what we need to define is the recipient, the NFT contract we're going to be minting on, and the token ID we want to mint. And after we have all of this, then we get a user op hash, user op receipt, and return this back to the client. So well, that's not supposed to happen. Apologies. Let's do a live. Well, this was working just before I came back up, unfortunately, for us. But I have this pushed, a working version of it, to a repo that if you go to smartwallet.dev, we have all of this documentation here on spend permissions, including a basic overview, the quick start that has the sample experience Lucas just demoed as well. And then within here, if you go to the this one, Zora branch, you can access all of this code here within the app, and then we have a mint route that is doing this kind of API work. I'm curious, from the crowd, are there any applications that people are keen to build with something like spend permissions / session keys? Yeah.
So we are building like a generative art platform. So like the idea could be that like you as a collector, you can like approve spending, and each time like new mints come, it's automatically minted on your behalf, so you don't need to wait in front of the like minting button and refreshing the page. So that could be probably like idea I would have like with this.
That's cool. So this is something where as soon as a new token becomes available, like on the drop, I can mint?
Yes, exactly. So we have like weekly drops. So users don't need to wait like at, for example, 3 p.m. They don't need to wait. Like you see all the mouses going around because we have like a party kit. So you see all the like pointers. So they are impatiently clicking on the mint when it becomes like pink. So yeah, you approve your minting, and that's it. So at 3 p.m. sharp, you can mint for everyone who approved the limit.
Yeah, I love
could
that.
be nice.
I like how in particular it helps people not be perennially online. And so this is a good
Yes.
use case of like the background
Yes,
transactions
yes.
use case.
And we are already live on base, so happy to try it on.
I love it. Well, we skipped most of the workshop by having the code pre-pushed because we didn't want people to worry about typing live with us. So if people would like to build something together, we're here to finish the rest of the workshop. But otherwise, I think we have most of the content that we wanted to cover actually, and then leave the rest of it open-ended for what people wanted to build live.
So is the batch atomic or not? Or how does it work?
The batching on Smart Wallet is
Yes.
atomic. Yeah,
Okay.
it's only atomic.
Nice, thanks.
Was the account you were using to execute the Uniswap transaction in the example an EOA account, or is that another smart wallet?
In this one?
The Mint2 or the Uniswap, yeah.
Yeah.
The server account, what kind of account is that?
It could be any account that supports batching.
Okay.
So for us, we would just use the Smart Wallet because we know those contracts, but you can use anything as well up there.
Cool.
Yeah. It also doesn't have to be a 4337 account. It could just be a contract that supports batching. So like multi-calling, for example. Who is the one that calls execute on something like a server account? If it's a 4337 account, it would be the entry point because it's what's validating that you are actually you with your server key. And so after you validate your user op, then it'll submit a transaction or a call through the server account to then execute whatever batch you have. Yeah, another question. Yeah, correct. This entry point is the 4337 entry point.
Yeah, and so you guys created one more contract, which is the spend permission contract. This 7528. I'm a little confused. Can you explain what exactly is happening in the spend permission contract?
Yeah, what is happening in spend permissions? We can actually look at the code to show you some of the logic at play. It's relatively simple, but when you call spend on it, okay, this actually is going to be more complex than I was thinking. So when you do spend, it's going to do two things. It's going to validate all of the internal logic of, is this spending the right token? Is it spending too much of it for the current period? Part of the logic of spend permissions that's different from something like permit 2 or normal ERC20 approval is that there is a natural refresh of the permission over time. And so when you have a permission, I guess what Lucas showed you earlier, it was a TypeScript object. Here's the solidity struct we have. This period value is actually very important because it's what defines how long you go before you reset to 0. So for a subscription example, you would want the period to be your billing cycle. So 1 month, 1 year, bi-weekly, whatever it may be. For something like microtransactions, we've seen daily as like the most common way to do this. And so what the spend permission manager needs to enforce is that for the current period, have you spent more, have you spent up to the allowance? So if we go to use spend permission, that's what it's trying to do. So we just make sure that it's approved in some state that we have. If it's already approved in state, we look at what is the current period. Is the total spend for this period greater than what the allowance should be? And then if it is, it will fail. And otherwise, we can update our last tracked spend for the period. And so we would take the total spend and set it to the value, save it back in storage, and then emit an event that the spend permission has been used. And then after this, we would actually execute the ERC20 or ETH transfer.
So you mentioned in the beginning that we could fork this contract and then change something. What exactly was that? Oh, okay.
That would be this one, the execute. So the transfer from is just a normal transfer of either if it's native token, it'll call on the account to transfer value to the recipient. If it's an ERC20, it'll call the token contract itself with the transfer function, defining the recipient and the value. It's really this execute internal that you can switch. So for us, we just import the Coinbase Smart Wallet interface, and we call its execute function. So whatever account you have, you can just replace this. Yeah. Do you have more you want to go through? Yeah, let's try to fix the demo. Yeah. Actually, maybe we could help debug his thing as well. Red shirt. Yeah. 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 I want to take a moment to see if I can actually debug what was wrong with this minting, because it was working momentarily before. I thought I commented back in. Yeah, that's a good call. We all have the subscribe case. Actually, there is one more thing we should probably touch on as well that wasn't hit, which is people who want to build applications that have without a database. Hopefully that's like a lot of apps, at least many apps. They can use the blockchain as their database. One thing we've noticed is a need for providing index data about how many permissions have been used or how many permissions does your app already have. And so we've created a new RPC, wallet fetch permissions, that allows for that, where via API, you can always ping to know what permissions your spender actually has. And so you just provide the chain ID you're asking for. In this case, it only supports basic Polya, but soon everything else. Your spender address, that would be the server account in the examples we've been giving. And then what you get returned back is an array of these permissions. And for each permission, you would have all the fields and then the signature you need to apply. And for something like this, you would imagine a subscription would pull all of the accounts I have permissions for on a routine basis, and then for each of them, prepare this massive batch call to call spend on all of the users. And so fetch permissions is something that we're also hesitant to go too deep into with something like an ERC, because we'd rather make sure the interface makes sense first through production experience. But patterns like this we also see as important for building full stack apps, kind of completing the CRUD, where you can create permissions. You also need an ability to read permissions. Soon we also need to add an ability for you to update a permission. For example, if you have a subscription that's $10 a month, but you want to upgrade someone to Pro, you need to say, would you like to upgrade? You were on 10, we're going to remove that, and only conditionally on removing it will we add a new permission for $50 a month. And then the final of delete, we already support revoking, but also being able to prompt to revoke from the app side as well.
Yeah, if there are no other questions, I think we can end early here. But Connor and I will be around if anyone wants to try out the repo or just has any questions about spend permissions in general. We're happy to hang around and chat.
Cool.
Thank you.
you.